Hello everyone, welcome. In this video, we will be taking a look at 50 questions that are very important with respect to the upcoming next exam. We have analyzed the distribution of topics in all the previous years. We have analyzed how the difficulty level of question has been changing over the years and how many difficult questions there are, how many easy questions there are each and every year. And we have compiled these 50 questions. If you understand these questions in these last few days leading up to the exam, then you will be in a very strong position. We will have a very big advantage when you will be writing the paper. So please, as this video goes on, solve these questions side by side by yourself. You can pause the video in between if you are stuck on any question, and let us start discussing them. In the first question, we have been given the energy of some system in the form of an integral. Now we are given A, B and C as non-zero constants. They can be negative, they can be positive also. We have been asked the dimensional formula of the quantity B upon A. So we need not integrate this function in its entirety. All we need is the dimensions of each and every constants. Now we know that the integral leads to energy at the end. So the dimensionality of this entire integral should be equal to the dimensions of energy. And since the integral is with respect to x, the dx term will also add a dimension of length to the integral, and at the end we need the dimensions of energy. So everything in this square brackets, each and every term in the integral has to have directions of energy and length inverse. Only then will the dimensions get balanced and we will get a energy term at the very end. That means second derivative of phi also has a dimensions of, derivative of phi square has dimensions of energy per length. Let us write that down first. d phi by dx square. If we write the dimensionality of this, the dimensions of this quantity are dimensions of energy and length inverse, which means the dimensions of d phi by dx need to have the dimensions energy power half and L power minus half. We know that dx has dimensions of L, so dimensions of phi from here will be energy power half, length power minus half multiplied by length. So simply energy power half and length power half are the dimensions of phi as we have calculated from here. Now we need the dimensions of constants B upon A. Let us look at this term e power alpha phi and x. From here we can see that there is a mathematical function e power a into phi given to us. Now since e is a mathematical function, it only accepts arguments that are real numbers. This is a very basic fact in physics, that any mathematical function, be it e power x, log of x, sine, cos, any trigonometric function of x, whatever is inside these numbers has to be a dimensionless quantity. We cannot have a physical quantity as the argument of a mathematical function. So whatever is inside this exponential function has to be dimensionless by definition. So from here we have the fact that dimensions of A and dimensions of phi are dimensionless, so 1. And we can write dimensions of A as dimensions of phi to the power minus 1. So from here we'll get dimensions of A also, since we have the dimensions of phi already. And this term B into phi to the power 4 should also have the dimensions of energy per length. So dimensions of B into dimensions of phi to the power 4 also has to be of the same dimensions, E into L raised to minus 1. So from here we'll get the dimensional formula of B also as energy into length raised to minus 1 into dimensions of 5 raised to minus 4. and we had A as simply phi raised to minus 1. So the dimensionality of B upon A will simply be energy length inverse and dimensions of phi raised to minus 4 upon dimensions of phi raised to minus 1. Minus 4 and minus 1 will give us dimensions of phi raised to minus 3, and since dimensions of phi are e power half and L power half, phi raised to minus 3 will have the dimensions of energy power minus of 3 by 2 and length power also minus of 3 by 2. So the contribution of L from this formula will simply be 1 plus 3 by 2. 1 plus 3 by 2 will be the contribution of L over here. So 7 by 2 here, only fraction form is 7 by 2. This has to be the dimensional formula of the A upon B. Again, if we expand E as mass into length square into time raised to minus 2, then we can split them into M, L and T constants. So this is basically energy, let me write a little smaller, energy and length raised to minus 1 into energy half, length half raised to minus of 3. Simply substituting the value of energy, that is M L raised to 2 L T raised to minus 2 will give us exactly the dimensional formula of this one. Again, this was very easy. Let's look at the next question. In this question, we have been given a heavy wedge. Heavy means it is not movable by any motion happening on top of it. It is basically fixed. The meaning for heavy over here is that the wedge is fixed to the ground. Let us draw a wedge like this. The wedge is fixed to the ground and base angles are given as alpha and beta. So we can draw the wedge something like this. This angle will be alpha, this angle will be beta, and we have been given that a projectile launched from one of its end at some angle theta with respect to the x-axis with some speed u has to exactly graze the top and land at the other end of the base. This is how the trajectory of the projectile will play out. Let me draw it a little more smoothly. Yes, this will be the trajectory of the projectile. Let the topmost point, apex, have coordinates x and y. Now we know that this point should lie on both the wedge and the trajectory also. This may or may not be the topmost point of the parabola, that is the maximum height, but it is the topmost point of the wedge. So if we draw a perpendicular from here, then we can see that this angle alpha, tan alpha will be equal to this height, which is y, and the distance between these 2 points is given as x, the distance between these 2 points being the total range of the projectile r minus of x. So simply going by this wedge, we can write the values of tan alpha and tan beta. Value of tan alpha from this wedge will be equal to simply y upon x, and the value of tan beta will be equal to y upon r minus of x. This is tan alpha and tan beta that we are getting. Now, this point x comma y should also lie on the trajectory of this projectile. For that, we can write down the equation of trajectory. Now, equation of trajectory can be written down in two forms. You can either use the form that explicitly states u and theta, that explicitly rates u, cos theta, cos phi theta, everything, or since we know that the other point has to be on the base of the wedge, that is the horizontal range of the projectile, we know is constant. So we can use the equation of trajectory that relates x and y to the horizontal range of the projectile. Equation of trajectory just becomes y is equal to x tan theta into 1 minus x by r. This is the equation of trajectory in terms of the horizontal range r. If we simplify this bracket term a little, we will get x tan theta into r minus x upon r. This will be equal to y. And if we take this x to the other side, we will get y upon x is equal to such an expression. Simply from the equation of trajectory, we are able to write this expression. Now we know y upon x is tan alpha and y upon r minus of x is equal to tan beta, right? We know this much. Y upon r minus x is the value tan beta. So if we take r minus x upon r to the other side, we will get tan theta equal to y upon x into r upon x minus of r. This is the value of tan theta which we get. Now we can see that if we add y upon x plus y upon r minus x, let us see what we are left with. Let me hide this for now. And let us add tan alpha plus tan beta from this expression, y upon x plus y upon r minus x. Simplifying the numerators by taking common denominator, we will get r minus x into y plus x into y upon x into r minus x. Minus of xy and minus plus xy will get cancelled. So we are left with y into r upon x into r minus x. That is, let me make this a little bit smaller to make space for writing other things. Yeah, and this will be simplified to y upon x will come on one side because we have r into y upon x into r minus x, and r upon r minus of x will remain in this question. So we can see that tan theta y upon x into r upon r minus x is simply equal to tan of alpha plus beta. We can make it explicitly by writing tan theta is equal to y upon x into r upon r minus of x over here. We can see tan theta is exactly equal to tan alpha plus tan beta. So we have theta is equal to tan inverse of tan alpha plus tan beta, that is sin alpha upon cos alpha plus sin beta upon cos beta. If we choose to expand alpha and beta, we will get from this equation. Again, this problem is very, very interesting because this is exactly the problem that scientists had to solve in order to invent a ballistic missile. That is, we need to find the projectile angle such that our projectile lands at a target spot and also passes through one particular point. We are basically finding what projectile will pass through this point and land at another point. That is exactly what a missile is. You launch a missile from here, it has to pass through some safety point for it to not get detected by any defense systems, and it has to land at one particular target. Nest loves these kind of questions that are not only mathematically interesting and are quite lengthy to solve, but also they have some real life connection. Let's look at the next question now. In this question, we have a stone projected from some point at a height of h, and we need it to land perpendicularly, right? It should land perpendicularly, determine the velocity of rotation. Yes, it has to land perpendicularly with the inclined plane. We have been given that the angle of inclined plane is y. So if we draw a perpendicular over here, let me draw perpendicular properly. If we draw a perpendicular over here and extend the ground, this angle should be 90 degrees, right? This angle is 90 degrees, which is perpendicular to the theta. which means this angle should be 90 degrees minus of theta. Just by completing the triangle, we get the angle as 90 degree minus theta. Now if we draw another perpendicular over here, this will be perpendicular to the ground, and hence we will get the angle between the perpendicular and the vertical y-axis for us will also be theta. It's a very standard result that if the inclined plane makes an angle theta with the horizontal, the normal to the inclined plane will make an angle theta with the vertical. If you guys have been practicing projectile motion, then this fact will have been memorized by you by now. Alright, now let us try to find out what should be the value of the initial projection velocity. Now, since this is an inclined plane, it will be easier to rotate our x and y axis, x along the inclined plane and y along the perpendicular. So let us rotate our axes. This will be our new x axis that makes an angle of theta with the ground, and this will be our new y axis. Let's call it y dash, and let's call this x dash. We know that projection is happening from some point over here. Its initial velocity is v naught. We can now resolve this initial velocity in terms of our y dash and x dash components. We know that angle with the horizontal is given as theta, so this component should be v naught into cos theta, and this component should be v naught into sin theta. We can resolve our velocities in x dash and y dash components. And acceleration due to gravity also we can resolve along the x dash and y dash components. X dash component, we know angle with the vertical is theta, so the y dash component will be g into cos theta, and x dash component will be g into sin theta. Now, since the projectile lands perpendicularly to the inclined plane, it should have zero velocity in the x dash direction. Velocity v dash x component should be equal to 0, which is the condition required from the question. So let us write down the x dash and y dash components of the velocity. Now, since there is acceleration both in the x dash and y dash regions, in the x dash and y dash direction, there is acceleration, right? So we can write the x dash component of velocity, vx dash, as the initial x component is v cos theta, v naught cos theta, minus of acceleration time x dash acceleration is g sin theta into t. Let t be the time it takes to land, right? So we can write, since we require this to be 0, v cos theta should be equal to g sin theta, or the time taken to land we can write as v naught into cos theta upon sin theta, which is simply cot theta. We can write the time taken to land as v naught into cot theta, from the condition that there should be no x dash component present when it lands. V naught by g will come over here. V naught by g into cot theta will be the time taken by the projectile to land. And we can also calculate this time taken by considering the y dash component of the motion. There is some acceleration g cos theta in the y dash direction, and we know that since it is released from a height h, this height is given to us as h. If we drop a perpendicular, this will be the distance travelled in the y dash direction. Since this angle is theta, this angle should be 90 degrees minus of theta, right? And since this height is opposite to this angle, the y dash displacement should be equal to h into sine of 90 minus theta, which is simply h cos theta, should be the height in which the perpendicular travels. Now, since this is the height in the y direction, we can use the displacement equation h cos theta should be equal to ut minus half gt square. initial was v naught into sine theta into t minus g cos theta by 2 into t square should be the value of h cos theta, which is the displacement in the y direction. Right? We already know the value of time. We can substitute it into this expression and finally get the value h cos theta should be equal to v naught into sine theta into v naught by g cos theta. Cot theta we can write as cos theta upon sine theta minus of g cos theta by 2. T square we can write as v naught square upon g square into cos square theta upon sine square theta. Yes, this is done. Now, as we expect, one sine theta will get cancelled from here, one g will get cancelled with one g square. Cos theta we can take common and we can cancel one cos theta on both the sides. We need the value of v naught finally. So v naught square we can take common from here, and whatever is remaining in the expression we can send it to the RHS, which will get multiplied with h. So this equation becomes we can take g and 2g from here, multiplying and dividing by 2. 2 into g into h goes to the LHS, and this will be equal to 2 v naught square plus cos square theta upon sin square theta will just be cot square theta. Sorry, this is minus of v naught square into cot square theta. So v naught will be simply 2gh upon 2 minus of cot square theta will be the answer. Sorry, 2 plus cos square theta, yes, 2 plus cos theta, because it is accelerating, right? Yeah, it is accelerating. So 2 plus cos theta will be the answer. 2 plus 2 cot square theta. Option B we can see clearly matches 2gh upon 2 plus 2 cot theta. Again, this was a very straightforward question, very doable, as long as you know inclined plane very well. If you have been practicing enough inclined plane problems, then this problem should not have been of much difficulty. Let's look at the next question. In this one, we have been given a rocket is fired vertically from the ground such that it has a resultant acceleration of 10 meter per second square upwards. So when it has this resultant acceleration 10 meter per second square, it will keep traveling with some constant acceleration. Constant acceleration, which is 10 meter per second square, is given to us, and it will reach some height, let's say h1. When the fuel is finished in 1 minute, so this should take 60 seconds, it will keep ascending until it comes to rest at the topmost point. Let's call this height as h2. Right? It will keep ascending and then it will fall back to the ground. We need the approximate value of this h2 height which we have taken. Now we can calculate h1 very easily. h1, since it is fired vertically from rest, it will simply be half a t square, that is 10 by 2, half into a into 60 square is 3600. That is 18 into 10 power 3 meters, right? 18 kilometers will be the first height h1 according to our solution, right? And by then it will have also gained a speed of v is equal to u a into t. Let's call this speed as u. This speed u will be a into t, that is 10 into 60, 600 meter per second will be the speed when it reaches the point h1. Now from here it will be moving under the gravity of the earth, right? And we know that the acceleration at any height h above the Earth's surface is given by the electric field at that particular point, which is simply g into mass of Earth upon radius of Earth plus h, the whole square. This is the acceleration due to gravity at any point, but we know that the object comes to a rest at its maximum height of trajectory, so we can simply equate its energy at this point and at this point and find what should be the height h2. The energy, gravitational potential energy, is equal to minus g into m into small m upon r plus whatever height h the object is at, right? So equating energy between these 2 points, let me shift all of these terms on one side. Yes, equating energy at the 2 points, we get initially object has some kinetic energy, half into m into v square. We know the value of v from here. Let's write as u. Half into m into u square is the initial kinetic energy, minus of g into m upon r plus h1. We know the value of h1 also, and this should be equal to simply the potential energy minus of g into m to m also upon r plus h2. We need to calculate the value of h2. We have been given all the other values, g, m and r, also radius of the Earth we have been given, right? M gets cancelled from each and every side. We can write u square by 2 as 36 into 10 power 4 upon 2. 36 into 10 power 4 upon 2 will be equal to 18 into 10 power 4, that is 180 kilometers. Let's express everything in kilometers for now. Minus of g into m. G is 6.6 and mass of the Earth is 6. So it will be approximately 40. 6 into 6.6 is approximately 40 into 10 power 13. 10 power 13 kilometers upon r plus h1 is there. R is 6.4 into 10 power 6. So we can write r as 6.4 into 10 power 3 kilometers. Now, of course, this is much more than 18 kilometers. So we can approximately write it as simply 6.4 into 10 power 3 kilometers is there, right? So this will be 6,400 kilometers. So the value of r plus h1 will be 6418 kilometers. 6418 kilometers will be on the denominator, and in the numerator we have 40 into 10 power 13. 40 into 10 power 13 meters. So 40 into 10 power 10 meters we have in the numerator. And the same thing will be in the RHS also. G into m value is common in both cases, right? So we can even take the value of gm common and equate this to g into m into 1 upon r plus h1 minus 1 upon r plus h2. If we simplify the numerator and denominator, we will get h2 minus h1 in the numerator. h2 minus h1 will be left in the numerator, and r plus h1 into r plus h2 will be in the denominator. That's it. All we need to do now is simplify these values and get the final value of h2. There is 180 at the very end, and this is 6418 kilometers. In the numerator, we will have 40 into 10 power minus 13, and in the denominator 40 into 10 power 13 gets cancelled with 6418 into 10 power 3. 40 will approximately cancel with 64 and give us 16. So this will approximately be 1 upon 16 into 10 power 10, which simplifies to 1 upon 16 is 0.25 into 0.25, that is 0.06, approximately 0.06 into 10 power 10 is there, that is 6 into 10 power 8. 6 into 10 power 8 it gets reduced to, and we can even neglect this h2 with respect to r and simply write 6 into 10 power 8 upon 64 into 10 power 3. So this entire bracket will get simplified to h2 minus h1, that is 18 kilometers obviously, into 6 into 10 power 8 upon 64 into 10 power 3, which is approximately 1 upon 11, that is 0.9 into 10 power 5. 0.9 into 10 power 5 is what we are getting from this. And if we take it to the LHS, 0.9 10 power minus 0.9 10 power 5 will be 64 upon 6 into 10 power minus of 5 from here. 64 upon 6. So that will be 180 into 64 upon 6. This gives us 30 into 64 in 10 power minus 5, of course. So 10 power minus 3, right? Yeah, multiplying this we get 18 4, so 190, little greater than 19, so it will be greater than 20 also. No, it will not be, yeah, it will be a little greater than 20, but it will not be greater than 30. Yeah, it will be very, very less than 30 at the very end if we add, and yeah, it will be greater than 20 only. So the final answer we will get h minus 18 should approximately be equal to 20, approximately 20 we are getting. So approximately 38 or 39 will be the answer that matches. Again, as long as you can see that when we have been given the resultant acceleration, we can just use the kinematic equation, and onwards we have to use the theory of gravity in order to solve it completely. We can get the answer. Let's look at the next question. This question says that there is a plane lamina ABC in the form of an equilateral triangle. So let us draw an equilateral triangle over here. This is the value of ABC that we have. This is a triangle ABC. Let's label it A, B and C point at the very, very end. Now we have been given that the moment of inertia along its centroid, this is centroid G, is I naught. Moment of inertia about centroid is given to us as I naught. Now, if we delete DE, D is the midpoint of this line and E is the midpoint of this line. Since it's an equilateral triangle, the line joining them has to be exactly straight. We are deleting this particular portion, CDE triangle we are deleting, and the only thing that is remaining, oh wait, this is AB and AC, right? So they have labeled this point as B in the question and this point as C is labeled, nothing more, nothing more. This is how we are labeling it. Yeah, and now we need to calculate the moment of inertia about this remaining ADEC around the centroid itself. All we need to do is subtract the moment of inertia of this triangle with respect to the centroid. That is all. Now we know that this particular equilateral triangle B, D and E has a length of A by 2. If A is the original distance AB, then this side DB will be A by 2. Right? Now the centroid of this triangle will be somewhere over here, and the moment of inertia of this triangle around this centroid we can write as I1, let's say, is equal to, we know the moment of inertia about G of ABC was I0, right? Now, since the side length of this triangle is half, then the area of this triangle will be 1/4. So, if the area is A of triangle ABC, then the area of triangle DBE will simply be A by 4, right? And hence the mass of triangle DBE will be equal to mass of triangle ABC, which is, let's write as M. The mass of ABC, let's write as M upon 4 we can write. You can easily see that mass of this triangle is 1/4 times the mass of the entire triangle. You need not worry about the area. You can simply see that if we construct two triangles such as this, all of these triangles are identical to DBE because they are equilateral triangles. So 1, 2, 3 and 4. The entire triangle is made up of 4 such triangles DBE. Hence the mass has to be 1/4 of the total mass of ABC. So now we can calculate the moment of inertia of triangle DBE about its own centroid and represent it in terms of I0. Now, since we know that the moment of inertia is proportional to mass into length square of triangles, then if the mass gets reduced to M by 4 and length gets also reduced to L square by 4, is half, right? It's L square by 4, which means the entire moment of inertia will get reduced to I upon 16. I upon 16 will be the moment of inertia of DBE with respect to their own centroid G dash. Let's call that centroid as G dash, for example. Right? Now we can calculate this moment of inertia, yes, and leave it as I0 by 16. I0 by 16 will be the moment of inertia. Why? Because length is halved and mass is 1/4 of the original mass. So I0 by 16 will be the moment of inertia of this triangle, which we need to subtract. Of course, we are subtracting. But this moment of inertia is not around this centroid. It is around this particular centroid. We need to calculate the moment of inertia around the centroid G. For that, we can use parallel axis theorem. Parallel axis theorem we can use, and the moment of inertia of the total triangle ADEC should be moment of inertia of this plus the moment of inertia of DBE around the same centroid, right? So ADE moment of inertia we can now rename. Wait, they haven't even, okay, my labeling is very off. This point was supposed to be A according to question, and this point was supposed to be B. That's it. Now calculations are affected. Here we have calculated triangle ADE moment of inertia about the centroid, which is original I0 upon 16 we get from here, right? Yeah, so BDEC we need to calculate the moment of inertia remaining, right? Now we can write the moment of inertia of triangle ADE, which we already have, will be equal to the moment of inertia of this particular triangle, let's call this point as F. So BDF, DEF, everything, the moment of inertia should be exactly the same, right? And we can write it simply as I1. Now, since we know the moment of inertia of DEF with respect to centroid is exactly the same, that is I0 by 16. I0 by 16, we know the moment of inertia of each and every individual small triangular elements, one of which we are removing from the main figure. So let us try and calculate the distance of the centroid G from A. Now, of course, this is a standard result. The distance of centroid from A for an equilateral triangle is simply the side length upon root 3. But if you don't have this result memorized, then we can see that for an equilateral triangle, since the angle is 60 degrees, the height should be side A into sine 60 degrees, that is root 3 by 2 into A. And the property of the centroid is that it divides the medians in the ratio 2:1. Again, from solution of triangles, we know that centroid divides medians in the ratio 2:1. So distance of centroid from G, A into AG distance, we can write as 2/3, which is the portion of the median that lies before the centroid, 2/3 into the height, that is root 3 by 2A, root 3 by 2 times A. This will be 2 and 2 will get cancelled, root 3. So A upon the root 3 is the distance of centroid from the point A. If you have not memorized this result, I highly recommend you to memorize. Otherwise, it's a very, very small calculation. As long as you know the properties of triangles from math section, you can easily calculate this distance whenever required. And since the centroid G dash is the centroid of half of its length, so that means we can also write distance from A to G dash as A upon 2 root 3, since it is centroid for a triangle of half its length. That means the distance between these two centroids simply is A by 2 into root 3. So the moment of inertia that we are subtracting from parallel axis theorem should be equal to I1 plus md squared. So I1 with respect to G will be equal to I1 plus md square, where d is simply the distance between the two centroids. Distance between centroids, let's write as AG minus of AG dash, that is d, which we can write as A by root 3 minus A by 2 root 3. A by 2 into root 3 will be the distance between centroids, and hence d square should be equal to A square upon 2 root 3 square, that is 4 into root 3, that is 12. 12 will be the distance d square. That's it. Now, if we just subtract the values of the moment of inertia, we will get I0 minus of I0 by 16 plus mass of this m by 4 into d square. We know the value of d square already as A square by 12. So we can write m into A square by 12 as simply I0 by 12. Once again, I0 by 12 will come over here, and from here we can write down the value of this bracket as simply I0 by 16 plus I0 by 4 into 12, 48. 4 plus 1, 5, I0 by 16. Yeah, we are getting the value as 5 I0 by 16, or 5 by 16 I0. And this is nothing but 11 by 16 I naught, we are getting the total moment of inertia of the figure. Option D matches. Option D we can see is matching over here. So once again, if you are familiar with all of the 4 subjects, a lot of properties of triangles are relevant in physics, not only in questions related to geometry of solid figures, but also in chapters like wave optics. We will see we need a lot of theory from maths. So please ensure that you don't neglect maths, otherwise your physics section will also not go great. Let's look at the next question. In this question, we have a solid wedge resting on ground, is in shape of a right angle triangle. So let us draw this wedge first. This is a wedge, and we have a solid sphere that starts rolling from top, and by the time it reaches the bottom, because it is resting on smooth ground, the wedge itself will start moving with some velocity, right? It will start moving with some velocity. Let's write it down as v1 and v2. Velocity of the sphere and the velocity of wedge will be in the opposite directions, right? Now over here we know that there is no external force in the x direction. The only force acting in the system is gravity, which is in the y direction. Since there is no force in the x direction, we can conserve momentum along the x direction also, right? The momentum along the x direction we can conserve from here. Let's write as v1 and v2. Since this v1 is at an angle of theta with the horizontal, the momentum contribution of this should be v1 cos theta. But this value of v1 is with respect to the wedge itself, and we need to conserve momentum with respect to the ground, right? So we can conserve momentum as v1 cos theta minus of v2 will be the velocity in ground, should be equal to the velocity of the wedge, that is, sorry, m into this should be equal to m into v2. Since m and m are both the same, we can simply cancel all of their masses, and we have the relation between their both velocities as we can take v2 to the other side, and hence v1 will be equal to twice of v2 upon cos theta, where theta is of course the angle of the wedge. Here we have the value of v1 in terms of value of v2. Now, considering the other y component, we can conserve energy also. Initially, the sphere had energy mgh. If h is the height of the wedge given to us, then initial energy was mgh. This will be equal to the final kinetic energy of all of the points, right? We will consider the rotational as well as translational kinetic energy of the sphere. We can consider. So this energy of the sphere at the very end will be half into m into v1 cos theta. Sorry, we need half mv square, which is the final velocity, plus half into I into omega square. Now what will be the final velocity with respect to ground? We know that in the ground frame of reference, v1 has an x component velocity. Let's write it in this way. Velocity x component is v1 cos theta minus of v2, and the y component of velocity is simply v1 sin theta. So the resultant, the net velocity over here will simply be the sum of squares. This will be the net velocity v. So we can write the net velocity v as simply from Pythagoras theorem, that is v1 into cos theta minus of V2 the whole square plus V1 sin theta again a whole square. This will be the kinetic energy of the sphere, and the rotational kinetic energy of the sphere we can simply write down as half into moment of inertia is 2mr square by 5 into omega. Since it is pure rolling, the value of omega will be V upon R. So V square upon R square. We can now complete the work energy theorem equation. M gets cancelled from all the sides as usual, from all the terms M gets cancelled, and taking this 2 which is common to both the terms to the LHS, we have a simplified expression as, let me take this term to make space. In fact, we can also write this over here so that we have more space for work energy theorem calculation. Right? Does this look fine? Yeah, it looks fine. Let us move this entire equation now to the left hand side. Yeah. So now we can take this 2 to the other side, and we can take this 5, multiply it over here, and take 5 also common from both the terms. Right? But let us stick to 2gh over here. 2gh should be equal to, expanding this term, we get v1 square cos square theta minus of 2 into v1 cos v1 to v2 cos theta plus v2 square plus v1 square sin square theta plus v square or v1 square, sorry, v1 square upon 5, right? 2 v1 square upon 5 will be left from the rotational kinetic energy. This is the term remaining to us. Now we'll note that v1 square cos square theta plus v1 square sin square theta is simply v1 the whole square, and we need the value of v2. So if we substitute the value of v1 that we have from the original expression, we will get that v1 cos theta is equal to twice of v2. So v1 cos theta we can write as twice of v2, and we can write v1 into cos square theta, v1 square into cos square theta as also v2. v1 square cos square theta is equal to twice of v2 the whole square. Sorry, 4 times v2 square. Yeah, v1 square cos square theta is equal to 4 v2 square, we can write from here. Right? Now, if we substitute in this expression, we have v1 square, which is 4 into v2 square upon cos square theta, that is 4 v2 square into sec square theta. Right? 2gh we have equal to 4 v2 square into sec square theta minus of 2 into v1 cos theta, that is 2 into v2. So this will be minus of 4 into v2 square, 2 v2 from over here, and v1 cos theta is 2 v2 plus v2 square, that is v3 square, plus v1 square, again we can write as 4 v2 square upon cos square theta. So 8 into v2 square upon 5 sec square theta will be the final expression. Now this will just simplify to minus of 3, right? It simplifies to minus of 3, and taking it to the LHS, we get V0 will be common. 4 multiplying this everywhere, 20 minus of 15 plus 8. 20 plus 8 will be 28, and that will simplify to, with 2 will get cancelled, and 14 will remain. 14 sec square theta terms remain in the question, right? 14 sec square theta remains in the question, and plus 1, yeah, 14 sec square theta minus 5, and on the LHS we have the value of 2gh. So gh remains in the LHS, and we can now multiply this 5 everywhere. So the value of V2, that is of the wedge, we get as 14gh upon, sorry, 5gh upon 14 sec square theta minus 3. Since we want the value of V1, we want, substituting the expression, we can see that value will be option matching with C. C option is matching in the question. 5gh upon 14 sec square theta minus 5. You need not even complete the solution from here, since you know that there will be a term 4 into 520 plus 8, 28. 28 term with sec square theta will still be remaining over here. Oh wait, this sec square theta is in the numerator. 8 by 5 V2 square into sec square theta. You need not even complete the solution. You can simply see that sec square theta will be with 14 and mgh has to be with 5. So option C is the only option that is matching. Next question, we have a metallic spherical shell, inner radius R1 and outer radius R2. These kind of questions are very, very common in NEST. They have to do with radial flow of heat. So let us draw a spherical shell like this first. If this is a spherical shell, of course, two concentric spheres of radii, inner radius R1 and outer radius R2 has been given. R1 and R2 are the radii, right? We need to find the thermal conductance for radial flow of heat. If the thermal conductivity has been given as K, thermal conductance we can write as capital K is simply 1 upon the thermal resistance, and we know thermal resistance can be written as rho into L upon the surface area. But this is true for a rod. When heat flows through a rod, along its length we can use its cross sectional area as A and its length as L. But heat is not flowing in one direction, heat is flowing radially outwards for this, right? So what we can do is we can find an equivalent rod type structure in which heat flows along the length. So if we consider concentric spherical surfaces as each cross section area, then we can consider some spherical element of radius r. Let me draw that in green. Let me draw a spherical element in green of thickness r, sorry, radius r and thickness dr. This is our spherical element, and if we consider this spherical element to be like a rod, heat flows across its thickness. So the role of length will be played by thickness dr, and the role of area will be played by its surface area 4 pi r square. So we can write the thermal resistance of this element dr to be equal to the thermal conductivity 1 upon k, thermal resistivity, sorry, into length is dr upon the area is 4 into pi into r square. This will be the thermal resistance of one spherical shell like this. In order to find the net thermal resistance, all we need to do is integrate, because we have connected all of these in series, right? Integrating dr, 4 pi r square and k is just a constant, 4 pi r square. So 4 pi k is a constant, it will come outside 1 upon 4 pi k, and we will be integrating r square in the denominator with dr. Very, very simple integral. Let me make some space for this. Yeah, the resistance of this element we have calculated as dr, and we have to integrate this from r1 to r2, right? So the integral simply comes out to be 1 upon 4 pi k into minus of r1 from r1 to r2. So 1 upon r1 minus 1 upon r2. So very, very straightforward integral, dr by r square, very, very simple, right? Simplifying, we get the value of r as r2 minus r1 upon 4 pi k into r1 into r2. Inverse of this will be 4 pi k r1 r2 upon r2 minus r1. Very easily we can see option A is matching for us. Again, you don't need to know a lot in this. All you need to do is be able to imagine that a spherical element will have heat flowing across it. So thickness will play the role of length, and area, surface area, will play the role of area for this. And resistivity is simply 1 upon conductivity. This is the thermal resistance of this rod element. Now, next question we have, in an Atwood machine, there's a block M hung on one side. So let us draw an Atwood machine first. A simple pulley mass system. Let me draw a big pulley to hang both the objects. We have a mass M over here, right? And on the other side, we have a beaker, cylindrical beaker with some water in it, such that water is leaking out of the beaker with constant speed VE and constant rate of flow mu, that is given in the question. That means this flow will generate some upthrust. There will be some upthrust due to flow of water, right? Considering the tensions in the string as T, we need to calculate the acceleration of the block after t seconds. So let us say that the block is moving with acceleration a. So the cylinder will also be moving with the same acceleration in the upwards direction, right? We can first conserve forces on the block of mass m. But first let us calculate the values of upthrust and all of the forces, right? Since the rate of reduction of mass is constant, that is mu, the mass of the beaker at any time t will be given by initial mass m minus of mu into t. This is the mass of the beaker at any time t, and the upthrust that is experienced by the beaker will simply be rate of change of momentum. Since the velocity of efflux is constant, this will be mu into VE. Amount of upthrust will be experienced by the beaker, and since its mass is getting reduced, the weight of the beaker will also get reduced as time goes on, right? Now all we need to do is balance forces on both the objects. So balancing forces on the mass m, we get m into A should be equal to mg minus tension in the string T. So we'll get value of T from here as m into g minus m into A. We can write. Now balancing forces on the beaker, we get mass into acceleration of the beaker for any time t. We can write down the mass of beaker as m minus mu t. So m minus mu t into same acceleration A should be equal to now the tension in the string plus the upthrust minus its weight. Tension in the string plus upthrust minus m minus mu t into g should be the acceleration. Now we can substitute the value of tension in this expression and get an equation of the form. No. I don't think we should continue in the same line. We will need another line. The expressions will be quite long. So it is better if we write this expression on the right hand side. And now we can substitute the value of tension in this expression. And we know the value of F also. Opening all the brackets, we get m into A minus mu into T into A from the LHS should be equal to T, that is mg minus ma, plus the upthrust, that is mu into velocity of efflux, minus of mg plus mu tg, minus of mg plus mu into T into G. mg gets cancelled, plus and minus. One of the ma terms will go into the LHS to give us 2ma. We need all the acceleration terms on one side since we need to calculate the acceleration, right? So let's take all the acceleration terms on one side. We will just have twice of m minus mu t, twice of m minus of mu into t, with a will be on the LHS, and on the RHS we will have mu into VE plus mu into T into G. If we take mu common, taking mu common from here, we will get mu into GT plus VE. So VE plus GT we can write over here. So finally, the acceleration A becomes mu into VE plus GT upon 2m minus mu T. Option B is clearly matching from here. Again, very simple, as long as you consider all the forces acting in the system. If you miss even one force, then you will see that you are getting a very wrong answer. And the option that matches with that wrong answer will also be provided to you so that you can get negative marking nicely. Let's look at this question. We have a P versus U diagram, and we need to calculate the work done by this gas in this cycle. Now we know that the pressure at both is given to us, the values of pressure is given to us. Now we can consider the PU diagram to be a P versus T diagram roughly, because we know the U, internal energy, is a state function, right? Internal energy is a state function, so we can easily consider it to be a P versus U diagram. But fine, let us calculate the change in internal energy in all of these processes. We know that the process, let us label this as A, B, C and D. A, B, C, D, let this be the thermodynamic cyclic process. In this ABCD, we know that AB is an isobaric process and BC is an isothermal process because no internal energy is getting changed. So internal change in BC and AD both is 0. Delta U for BC will be equal to delta U for AD, and both will be equal to 0. And we know furthermore that delta U for AB will be negative of delta U for CD, right? Delta U for AB will be equal to minus delta U for CD, and its value we can calculate is 3600 minus 1800, that is 1800 calories. Since this is an internal energy change, we can write this for an monoatomic gas. We know a monoatomic gas, the change in internal energy is N into CV into delta T. CV for a monoatomic gas is simply 3 by 2, so 3 by 2 nRT, will be the value of change in internal energy, right? Sorry, nR delta T, not T, delta T. The difference in these two temperatures will be the value of change in internal energy. And if you notice that nR into delta T is simply delta of PV for this process. Keep this fact in mind. We will use this fact later on in the question. Now, let us calculate the work done in all of these three processes. For an isobaric process, the work done is simply nR into delta T, right? So, work done in AB, we can write as N into R into delta T, which is equal to, we know that 3 by 2 nRT is equal to 1800 calories. So from here we get the value of nR delta T as 1800 upon 3 by 2, which is 600 into 2, that is 1200 calories. So work done in AB will be equal to 1200 calories. And the work done in BC also we can easily see. Wait, first for CD, the work done will be inverse of this. So the work done for CD, first we can write as minus of 1200 calories. Now BC is an isothermal process. In an isothermal process, we can simply write the work done as the heat supplied in the constant temperature process, we can write it. And work done for BC we can write as N into R into T log of V2 minus V1 or V1 minus V2, which will simply be pressure at B upon pressure at C. Pressure at B and C we can write from here. Now the internal energy at this value B we know is 3600 calories. That is nothing but twice internal energy. We can write as 3 by 2 into nRT for any monatomic gas at any temperature, right? So nRT will be equal to 2 by 3 times U. 2 by 3 times U will be the value of nRT for this process. And we know the value of U at this point is 3600. So we can calculate the work done by BC as 2 by 3U, that is 2 by 3 into 3600 into log of pressure is increasing twice, so log of 2 will be the answer. Let us just write explicitly 4 on 2 so as guys don't get confused. So this will be 1200, 2400 log of 2 will be the work done in BC. And similarly the work done in DA, the work done for DA, if we calculate, let me write 2400 log 2 over here to save space, 2400 log of 2. The work done in DA, again we can write nRT as 2 by 3 into U. So work done in DA will be equal to negative because it is going from higher temperature to lower temperature. So higher pressure to lower pressure, right? Minus of 2 by 3 into, now energy is 1800 calories into log of 2. So this will be minus of 1200 log of 2. That's it. We now have the work done in all of these three processes. we can simply add them up. The work done by AB and CD will get cancelled, and if we find the total work done, net work done will simply be work of DA plus BC, that is 1200 to 4000 log of 2 minus 1200 log of 2. 1200 log of 2 is the option that is matching in this question. Again, very simple, no big deal at all. All you need to know is how to calculate the work done and the change in internal energy for various processes, and you can easily do this question also. Next question says that there's a vertical cylinder having an ideal gas at room temperature, at atmospheric pressure, which is basically room temperature also, and the cylinder has a movable piston at the bottom. Surface area of the piston we have been given, and mass of the piston also we have been given. Now it is said that gas is heated from this initial temperature to the final temperature. If the gas is heated, that is, it has been given some energy to increase its temperature, it will have to move the piston because it will expand. Gas expands on heating, so it will have to move the piston. Let us draw this system like this. It is a cylinder and we have a heavy piston somewhere. Heavy piston has some mass, so there will be some weight of the piston mg acting downwards, right? The pressure of the gas should exert some force P into A upwards while expanding. And when the piston is clamped and the gas is cooled back, this will be a isochoric process. Why? Because piston being stopped means the volume of the gas is now fixed, and as the piston rises freely, this should be an isobaric process because external pressure and internal pressure have to be equalized, right? So the initial heating process is isobaric and the final cooling process will be isochoric because piston is kept fixed and hence the volume of the gas is also constant. Now we have to find the difference between heat provided and the heat lost in the heating and cooling process respectively. Initially, for an isobaric process, we can calculate the work done as simply P into delta V. We know how much the temperature has been changed, so we can also calculate the work done P delta V. But since there is also the weight of the clamp which our gas pressure has to overcome while expanding, we can say that the work done during the process is equal to the work required to lift the piston to a height of h, right? That is also some energy that the gas will have to spend from its own internal energy. So work done by the gas in the heating process, let us calculate. Let us write down the work done by the gas in heating process as P into delta V plus mg into h, and we know what will be the height to which the piston rises. It is simply the change in volume delta V upon the cross section area of the piston, which is given to us 5 in 10 power minus 3 meter square is the cross sectional area of the piston. Now if we calculate the work done, the change in volume from the change in temperature, we can calculate. Initially the pressure is atmospheric pressure, that is 1 atmosphere or 10 power 5 Newton per meter square, right? So this will be 10 power 5 Newton per meter square into piston is rising by 10 centimeter, right? So we can write the value of delta V as simply A into 10. Area is 5 10 power minus 3 into 0.1 meters plus the weight of the piston is 50 into 0.1. So 5 joules will be the work done by lifting the piston. Now 10 power minus 3 into 0.1, 10 power minus 4 into 10 power 5 will be 50. Adding 5 over here, we will get exactly 55 joules is the work done just for heating of the gas. While heating of the gas, the work done is this much. And we also know the change in internal energy for heating of the gas is N into Cv into delta T. Initially for isobaric process, we could have written NC per delta T directly, but from the first law of thermodynamics, we can calculate the work done in heating. Sorry, heat required will be equal to delta U plus work done by the gas. Very, very important sign convention. Don't use the sign convention for chemistry. In chemistry, we are dealing with different systems. In physics, we are dealing with different systems. According to the chemistry sign convention, this has to be delta Q minus W. But in physics, we always write heat product as change in internal energy plus the work done by the gas. So now, the value of heat provided we can calculate by N into Cv into change in temperature is 50. So 50 into NCV we can write plus the work done is 55 joules. This will be the heat provided in the initial process. Now, in an isochoric process, for an isochoric process, there is no change in internal energy, right? So there is no work done. Since there is no work done, the heat, this is isobaric process, and the heat for the isochoric process now will simply be the change in internal energy, because there will be no work done by the system. The change in internal energy will be the same. Since it cools back to the same temperature, change in internal energy will still be 50 into NCV. Since we need the difference Q of P minus Q of V will be equal to 55 minus 50. That is 5 joules. Option A you can see is matching over here. Question is very, very easy. The only thing you need to know is again how to calculate the various thermodynamic quantities for various thermodynamic processes. Let's look at the next question. We have a tank of volume 5 liters containing this much amount of nitrogen gas. If 30% of the gas is dissociated into free atoms. So now the dissociation of atoms will cause these many amount of atoms to exert pressure, not in the way a gaseous nitrogen would, but in the way that a ideal monoatomic gas would exert pressure. Nitrogen is a diatomic gas. The gas made by free atoms would be an ideal monoatomic gas. So let us calculate how much will be the final pressure in the tank. Initial volume is 5 liters. Molecular weight of nitrogen we know is 28 grams. So the number of moles of nitrogen should have 1.4 upon 28, that is 0.5. Right, it has initially 0.5 moles. And the number of moles of gaseous nitrogen left will be 70%. So gaseous nitrogen N2 number of moles will be 70% of this value. So the number of moles will be 14, 7 cancel with 4, 1.4 upon 4 will be 0.35, and dividing additionally by 10 we will get 0.035 is the number of moles of nitrogen gas. Gaseous nitrogen will have 0.035 number of moles. Now let us calculate the number of moles of helium. We know molecular weight of helium is 4 grams, and if we have 0.4 grams of helium, the number of moles of gaseous helium will be 4.4 upon 4, that is 0.1 will be number of moles of helium, and the number of moles of nitrogen free atoms, that is N, will be again 1.4 upon 2.8 into 30%, that is 3 by 10, and this will be 0.035. I forgot to write 0.035. Yeah, 30% of this much will be 105, right? So 0.15 will be the number of moles. Whoa, wait. The number of, yeah, the molecular weight of gaseous nitrogen is 28, but for free nitrogen, the molecular weight is 14. So the number of moles will be 1.4 upon 14, that is 0.001 into 3, that is 0.03 will be the number of moles of free nitrogen atoms. Now, from the ideal gas equation, PV is equal to nRT holds for each gas, for each gaseous component. We can write the ideal gas equation PV equal to nRT, and here we can write P for nRT upon the volume of container, right? R into T for the units of atmosphere. For the units of atmosphere, we can write the value of R into T as the value of R is 0.08 in terms of atmosphere, and value of temperature is 1500 Kelvin given in the question, and volume is also 5 liters, that is constant. So 1500 kelvins upon 5 liters, T by V, we get just 300. 300 Kelvin remains if we subtract T by V, right? And multiplying with the ideal gas constant R, we will get ideal gas constant is 25 by 3, right? 25 by 3 is the approximate value of ideal gas constant in this equation. So the value will be 25 by 3 into 300, 2500. Yeah, 2500 will be the approximate value of RT, which we have to multiply with the sum total of all the moles. So the final pressure in the tank, will simply be the addition of all of the components, that is 0.03 plus 0.1 plus 0.035 plus 0.03. Yeah, and we can multiply this now with R into T by V, that is 300 R, it's 300 R, yes, into 300 R, 25 by 3, so we'll get multiplied 2500, and 0.035 plus 1, 0.135, 0.165, yeah, 0.165 is the total number of moles, and 300 R will give us an approximate value of 0.165 into 3 is 18, so approximately we should get a value a little bit greater than 4. Yeah, 4.125 atmosphere will be the approximate value. Oh, sorry, 4.125 will be the exact value. You can approximate this and you will see that it should be a little greater than 4. Let's go to the next question. Next, we have a small block sliding down inclined plane at angle theta, but the coefficient of friction on the block increases linearly with the distance that it travels down the incline. So let us sketch the system first. This is an inclined plane, angle theta we have been given symbolically, mass m starts from rest over here, and as it moves through a distance of x, the value of the coefficient of friction we can write as, wait, we can take x over here, and this block of mass m, we know weight mg will be acting downwards, and we can resolve mg into its components. Mg cos theta is the component perpendicular to incline, and mg sin theta is the component parallel down the incline, and it has a friction force acting backwards. Normal reaction force we can equate with the vertical component as mg cos theta. You can balance the force in the free body diagram itself in order to save time when you are actually solving in the exam, right? And mu naught into x into n will be the force of friction, right? We need the maximum speed that the block attains. For the value of maximum speed, we need dv by dt should be equal to 0. That is, acceleration should be equal to 0 when the speed is maximum. So that's it. We can now balance all the forces on the block and equate it to m into a, but the acceleration should be 0. So acceleration at any distance x we can calculate as driving force is mg sin theta. Mg sin theta is the driving force, and a friction of mu x into n, that is mu naught into x into mg cos theta will be equated to m into ax. Sorry, m into x is the acceleration. M will get cancelled as it always does, and we will get the acceleration a. Acceleration a we will get in terms of x as g sin theta minus mu x into cos theta, right? But when acceleration is equal to 0, we will get the value of x from here. So this value x naught we find as g sin theta upon mu cos theta, that is simply g tan theta by mu. G tan theta by mu naught will be the acceleration. Wait, sorry, g gets cancelled, so just tan theta by mu will be the place where acceleration is 0. Tan theta by mu is the position. Now to find the speed at this particular point, all we can do is we can write acceleration is equal to v dv by dx. V into dv by dx we can write as g sin theta minus of mu naught into x cos theta. Value of x we already know, right? Value of x is tan theta upon mu. So mu naught into sin theta upon mu cos theta, we can expand tan theta, and now multiplying by cos theta, one cos will cancelled, one mu also will get cancelled, right? Yeah. So v into dv by dx, wait, one of the mu will not get cancelled. No, mu does not get cancelled. One of the mu will stay. One mu will stay from the value of x naught. In fact, the entire mu will stay. Yeah, mu will not get cancelled. Only cos theta gets cancelled over here. Cos theta gets cancelled. the value of x naught, just if we substitute, we will get this particular expression. Now we need to integrate with respect to x on the RHS and with respect to v on the LHS, right? With respect to x, we will get v into dv, that is v square by 2 should be equal to integral of from 0 to some value of x naught. From 0 to x naught, we will, the integral comes out to be g sine theta. Oh, wait. Let us not substitute the value of x over here. Right now, we can substitute at the very end, yes. So, mu naught into x with g cos theta was there. We only need to integrate with respect to x. So, integrating for x naught, we will get the integral as g sine theta into x naught minus of mu naught into g cos theta x naught square by 2 will be the integral at x naught. Simply taking dx to the RHS, we can get this value. Yeah, that's it, the value of v. Putting the value of x naught and x naught square over here and then adding tan theta by mu is the value of x. So sine square theta upon cos theta will be in the first term and sine square theta upon 2 cos theta will be in the second term. Yes, exactly. So we will get v square, substituting the value of x naught from here, we get the value of v square as 2 into g sine square theta upon cos theta mu minus of g sine square theta upon cos theta into mu. So g sine square theta upon mu cos theta, mu naught with cos theta square root. Yeah, we can directly put a square root and cancel this v naught square. This will be the value of v naught at the point where its acceleration is 0, or this is the maximum value of v naught also. As we can see, option C is clearly matching over here. Let's look at the next question. In this question, we have a right angle wedge which is initially on a smooth surface. A block placed on it is shown. Now, when the block does not slide and if we move the wedge with a horizontal acceleration of a naught, we need to calculate what can be the maximum value such that the block just starts sliding. When the block is not sliding, we can calculate its acceleration as simply the acceleration of a naught. Simply a naught will be the value of the acceleration of the block 2 also when it is not sliding. But there will be some friction acting on the block 2 because the block 2 tries to move downwards along the incline. The friction will oppose such a downward slide, and at an angle alpha we will get some friction. This is mg and the component is mg cos alpha, which will be the normal reaction force N. Again, this free body diagram we have also applied in the previous question, last question. Friction will be coefficient of friction is given to us as k, so let us use that term only, k into mg cos theta, in this case mg cos alpha will be the value of the frictional force, right? Oh wait, not n because ma is the net acceleration. So ma with cos alpha should be the value of friction, right? We can write the value of normal reaction force over here as n balancing n should be equal to mg cos alpha minus of a naught into sin alpha, right? Mg cos alpha minus of m a naught cos alpha. Mg minus of m a naught will also be in the cos alpha. Oh, sorry, not cos alpha, sin alpha. M a naught with sin alpha, because the angle with the horizontal is given as theta. This angle will be 90 minus theta. And because of this, the value of the friction K into N will be equal to K into mg cos theta minus K into m a naught cos theta. Right? Now, since the block is not sliding, the force in the parallel direction also has to be balanced, right? That is m into g into sin alpha should get balanced by, sorry, there's also a net force m into a naught acting over here, right? So mg into sin alpha should get balanced by the friction force K into N also. K into N plus m a naught sin alpha will have to be balanced. So wait, first let us write m a naught term, m into a naught with cos alpha should get balanced with mg sin alpha down the incline minus of K into N. Substituting the value of N into the second equation, we can write ma naught cos alpha should be equal to mg sin alpha minus of K into mg cos alpha minus of K into ma naught into sin alpha. Since we need the value of a naught, let us take all the a naught terms to the one side with cos alpha minus of K into sin alpha. Cos alpha minus K sin alpha will be the coefficient of a naught. M gets cancelled. With a naught will remain, and on the RHS we will have G sin alpha minus K cos alpha. G sin alpha minus G into K cos alpha. Which option is matching? Let's see. G into sin alpha minus K cos alpha. Sin alpha minus K cos alpha. Wait. I think, yeah, sin alpha plus K cos alpha. And upon, oh wait, there's a plus sign here. There's a plus sign. I forgot about this. Yeah, minus into minus becomes plus, right? So sin alpha plus K cos alpha, option A and B might be right. In the denominator, we should have cos alpha minus K sin alpha. So option B is matching, we can see. Again, simple laws of motion question. If you can balance forces in all directions, no matter how the forces are created, remember always the forces need to be balanced. Let's look at the next question. In the next question, we have three marbles falling down. They are placed in close contact with each other. And since the size of the marbles is very, very small, we can consider that all of them fall with the same height h, and they will gain a velocity of u, that is under root of 2gh. After falling by the height h, we can assume that they all gain the same amount of speed after hitting the ground. Now we have been given that the mass of 1 is much greater than mass of 2, which is much greater than mass of 3, right? So until they are in the air, they are moving with the same acceleration, same velocity at each and every point. Hence, they will not collide until and unless one of them hits the floor. When mass m1 just hits the floor and gets rebound with the same speed, it will collide with mass m2 first. So the first collision will be between mass m2 and mass m1. m1 will be moving upwards with the same speed u that it had fallen down with. m2 will be moving downwards with the same speed u. This will be the first collision. Now, since the value of mass m1 is much greater than the value of mass m2, we can consider that this collision is nothing but a wall. This is a wall that was initially moving with a speed of u and a small object falling towards it with a speed of u. This is a very simple case. We know that a wall will keep moving with the same velocity u even after collision, and twice the velocity of the wall will get added to the initial speed. So after collision, we know that the final velocity is u plus 2u, that is 3 times u. 3 times u will be the final velocity of the mass m2, and the mass m1 will still keep moving with the same speed. So for a collision with a wall, we can say that after collision, the mass m continues moving with the same speed and mass m2 starts moving with 3 times u. Again, you can find these values explicitly by conserving momentum and applying conditions for elastic collision, but you will end up getting the same values after making approximation. m1 is much greater than m2. So don't bother writing each and every step. You don't have enough time to keep doing that for every question in the exam. Try to find out how you can increase your logical application and decrease your computational application. So we have now the final velocities of u and 3u. This mass m2 will now collide with the mass m3, and the second collision will be mass m3 moving downwards with speed u, and mass m2 will be moving upwards with a speed 3u, which we know from the previous expression, right? Same thing, we can assume that since mass m2 is much greater than mass m3, m3 is actually colliding with a wall that was moving with a speed 3u towards it initially. So same thing, twice of 3u will get added to u, and the final speed of m3 will be u plus 2 into 3 times u, that is 7 times u. 7 times u will be the final speed of m3, and m2 will keep moving with 3 times u even after the collision. So we have now the final speeds of m1, m2 and m3 in the ratio 1:3:7. We need the ratio of the maximum heights that each of the ball will attain once they stop. Now we know that this maximum height is given by u square by 2g, that is, it is proportional to v square by 2g. If v was the velocity of projection, it will be proportional to v square. Since we know the ratio of velocities, v1 is to v2 is to v3, we know as 1:3 is to 7. Hence the ratio of h1 is to h2 is to h3 will be 1:9 is to 49. Option A is exactly matching with our answer. This question would have been much lengthier. It would have taken me the entire board would be filled with equations if I had manually calculated each and every speed after putting approximations. But since I know that collision with a wall just adds twice the velocity of the wall, we can simplify our calculations very quickly. Again, you have to use smart work in exam and not hard work. Don't waste your time doing unnecessarily calculating. In the next question, we have a beaker which is spinning with a constant velocity omega, and we have been given the angle that any point x comma y makes with the horizontal. So the value of tan theta is given at this slope. Let us try to relate x and y over here. We know that, let's say, this tangent at this point we have drawn, and the curvature, if we draw over here, the curvature of this point, sorry, it's much greater. Yes, if we draw the curvature like this, then we know that at the very bottom, if this is the origin, if this value is the origin, then this point is given to us as x comma y. This point x comma y is given to us. If we complete this triangle over here, we can see that this angle which is given to us as theta, for this angle tan theta will be equal to simply y by x. We have been given the expression for tan theta. If we simply equate it to y upon x, because tan theta is y, which is the height, and x, which is the width at this point, right? So we will get from here y is proportional to x square. Y proportional to x square we are taking from this equation, because omega is a constant, g is also constant. We need to find the incorrect option. Option B says y is proportional to x square. Option A says y is proportional to x power 4. A is clearly incorrect, and since only one question is the answer, sorry, one option is the answer, option A is the required answer of this question. The rest of the options, we know that they will be correct. All you need to apply is the simple logic of tan theta. If you couldn't see this tan theta logic, then you would have wasted a lot of time. A lot of time will be wasted in actually calculating how the surface will behave, how you can equate the value of y and x to the focal length. Everything would have taken a lot of time. But since you know only one option is correct, you can simply write a y will not be proportional to x power 4. Let's look at the next question now. In this question, we have a uniform rod of length L, cross-section area S, everything is given in symbolic form, and it is moving on a smooth ground if a constant force F0 is acting on one of its ends. Let us construct the system first. This is the rod. F0 force is acting on one of the ends, and we need to calculate the total elongation in the rod. Let us consider a small length element at a distance of, x from the free end. We'll consider at a distance of x having thickness dx. Let us consider, right? Why are we doing this? Because since the rod is moving with a constant acceleration, each and every dx element of the rod will be accelerating, and so the tension at each and every dx element will be different. If the tension at each and every dx element is different, then Young's modulus expression we know is F into L upon A into delta L, where F is the force applied. In this case, the tension in the rod at some value x is being played the role of F. So in this case, the force of F is tension at a point in x. Length of the element dx we can write, and cross-section area A, and the elongation dl we can write over here. This does not mean that we get dx upon dl value over here. Dx and dl have very different meanings in this question, right? So each element dx will be expanded differently because tension at each element will be different. Let us try and calculate what will be the tension at exactly each x element. First of all, we know that the mass of this dx element dm, since the rod is uniform, the total mass of the rod upon length of the rod L will be the linear mass density, and multiplying it with length dx will give us the mass of the element dm. Now balancing forces on it, if the tension T is acting behind it and T plus dt tension is acting in front of it, then the net force around it, that is dt, the change in tension around the rod, should be equal to dm into the acceleration of the rod. We know acceleration of the rod is simply f naught upon the total mass of the rod. So we can write dt as the value of dm is m dx upon length of the rod L, and the value of acceleration, which is constant, is f naught upon m. M and m will get cancelled, and integrating the dx from 0 to some value of x, we will get the exact value of tension at any point 0 to x. We will get tension at any point x as f naught upon L into x. Now we can substitute this value in our expression to find out the change in the length dl of the element. So dl we can write as T upon ay. So 1 upon ay is constant, it will come outside. The value of a is further given as s. 1 upon sy is constant, it comes out of the integral, and we can now write the elongation dl as T into dx. Value of tension we know as f naught upon L into x with dx. This will be the elongation in one of the dx elements. If we need the total elongation, we can simply integrate all over the length of the rod 0 to L. So total elongation delta L will be given by x becomes x square by 2, substituting L square by 2. So f naught upon syl into L square by 2 gives us f naught into L upon 2 syl. L and L will also, they have already were cancelled, f naught L from here and L from there. So f naught upon 2 sy. Option is matching B. Yes, option B is matching in this question. Again, very easy. All you have to see is that each and every dx element expands differently. Each dx element expands differently. Just by observing this particular fact, you will get the change in length of one element, and hence you can integrate to find the total change in length also. Let's look at the next question. We have a device which produces sound as well as detects sound. It is a transmitter as well as a receiver, and it is moving towards one of the walls. The sound created by it will also be received by itself. The frequency of the source is given to us as Fs. So one of the frequencies heard by the detector will be Fs. We are asked which frequency will not be detected. Fs, one of the frequencies, will be detected. So option C is not the answer. Now when the sound will get reflected in this wall, it will get received, right? So we have to apply Doppler effect to see what is the frequency of sound heard by the wall, which will be the frequency of the sound emitted by the wall, and again applying Doppler effect, we will get the frequency of sound received by the detector. But we can simplify the calculation greatly by assuming that if this is a source moving with a speed v, then we can, if this is a source with speed v, then we can find the image of the source which will be moving with a speed v towards the wall. Consider the wall to be a mirror. We can find the mirror image of the source and imagine that that image source is emitting sound with the same frequency fs. So this will be one of the frequencies heard. Let's call it f1. And similarly, on the other side, we can construct an image source. It will be moving away from the mirror with a speed v, and this will also emit some sound, and the frequency heard, let us write as f2. We need to calculate f1 and f2. Doppler effect, if you know, frequency is equal to f naught into speed of sound c plus minus v upon c plus minus v, detector and source. Velocity of source always comes into the denominator and velocity of detector is always in the numerator, right? What is the sign convention we have to use over here? Source is moving towards the detector. Source is moving towards the detector, and detector is also moving towards the source. So frequency has to be increased in both the cases. So sign convention will be plus upon minus. And similarly, in the second case, the detector is moving away from the source and source is also moving away from the detector. So frequency has to be decreased in both the cases. So minus upon plus will be the sign convention that we will use in this case. So let's calculate f1 will be equal to frequency of source into c plus cv, plus v upon c minus v, and similarly f2 will be equal to fs to c minus v upon c plus v. So both of these will be heard, and option D is the only frequency that will not be heard. Very, very easy as long as you know Doppler effect and how to deal with reflection of sound waves by using mirror sources. You will easily solve this question also. In the next question, we have a star of radius rs and surface temperature Ts. Let us draw the system first. This is a star. It is emitting energy in all directions. Right? Energy is being emitted in all directions, and there's a planet at a distance of RSE. Everything we've been given. Right? We know that from Huygens principle, the intensity of waves decreases as they move with some distance, because the energy will spread along higher and higher surface areas. So the energy that is received by the planet will not be the same energy that was emitted by the star. It will get reduced by the amount of distance that the wave had to travel. So the power received by the planet will be equal to power emitted by the star upon 4 pi into RSE whole square. Distance between them is RSE. The power P will get distributed equally in a area of 4 pi r square. Hence the power received by the planet will be related to power emitted by star as this expression. Now we know the power emitted by the star Ps is simply sigma into 4 pi r s square into temperature of the star to the power 4. Stephen Boltzmann law, we know the power emitted by a star. Now, we have said that in the steady state, balance of energy between incoming and outgoing radiation causes the temperature of planet T E. So that means the planet at temperature Te is also emitting some energy as sigma into 4 pi radius of planet Re square into Te raised to 4, and this is equal to the energy that is getting received by the planet from the star. So this should be equal to Pe, that is 1 upon 4 pi RSE the whole square into sigma into 4 pi Rs square temperature of the star power 4. That's it. Since we only need how each quantity depends, then we can see from here T e to the power 4 is proportional to Ts to the power 4. Hence, Te will be proportional to Ts. Any option like this? No, there is no option like this. Let us check other proportionalities now. Te to the power 4 is equal to Rse square. So, Te will be proportional to 1 upon Rse to the power half. That is Rse to the power minus half will be the proportionality of Te. Any option matching? No, again no options matching. Option B says Re power minus 1, which is not true. Let us check the dependence on Rs now. Te is proportional to radius of the star raised to power half, because T raised to power 4 is equal to square. So yes, option D we can see is matching over here. And since sigma and sigma get cancelled on each side, the temperature does not depend on the Boltzmann's constant. So option D will be the correct answer of this question. Again, as long as you know Eisen's principle, even that was not required over here. That was just required to check how the temperature would depend on the distance between planet and star. If you had not done this step, then you would get that the temperature is independent of the the radius between star and E. So again, option B would still have been wrong for you. There is no loss if you don't remember that energy as emitted by a star gets distributed equally and hence reduces in intensity. Let us look at the next question. Similarly, in this question, we have been given a planet of radius r, which is 1/10 of the radius of the Earth, has a depth r by 5 well. So let us draw the planet here. In fact, we don't even need the full planet. All we need is the well, right? So let us just draw the well over here. And inside the well, we have a small wire. Oh no, sorry. The wire has the equal length as the well, and a wire is lowered into the well, just touching the bottom of it. It is not touching anywhere, so there will be no contact forces between the wire and any other surface. It has the same depth r by 5. Right, now let us r by 5 in terms of the radius of the Earth is Re by 50. So the Earth by 50 is the depth of the well. Again, just keep this number in mind. It might be useful later. Now, we need to calculate the amount of force required to hold the wire up, because gravity will be acting on each element of the wire. Now we know that inside a sphere, inside a solid sphere, the gravitational field inside a solid sphere at any depth r is given by E of r inside the sphere, or we can write r is less than capital R is equal to 4 pi into g upon 3, 4 pi into g upon 3 into rho r. This is the gravitational field acting. Even if you haven't memorized this result, you can calculate this result by considering Newton's shell theorem, that inside any solid sphere, only the amount of matter enclosed inside this shell gives us gravitational field. You can easily derive this result also, but I suggest you memorize this result by yourself. Now we can leave rho as it is. We can further we can further write down the value of rho as mass density of the earth, that is mass of the earth upon 4 by 3 pi into radius of the earth cube. We know the radius of the earth and we know the acceleration due to gravity of the earth. So gm upon r square is equal to g. We can calculate the value of m from here if you haven't memorized it again. But the value of capital M we were given in some previous question, right? I think in the very second question we had been given the value of the mass of the earth, 6 into 10 power 24. So like this you can verify your calculations from other questions in the same exam also. But regardless, let us focus on this question now. We can leave the density in terms of rho for now and substitute it later. We need to calculate the force required to be held up by the end. So if we consider a mass of element dx at a depth of x from the free end, then the force acting on this mass element df will be the force due to gravity, right? Force on this mass element df we can write as g into mass of the planet. Let us write as m as the mass of the planet. Oh sorry, we don't even need that. We have the value of electric gravitational field E into the mass, right? What is the mass of this element? The mass of this element is lambda into dx. Lambda dx is the mass of this element. So electric field into mass dx we can write down. We'll get the value of F as E is 4 pi g into rho. So 4 pi capital G rho lambda upon 3, and the radius is the radius of the total planet r minus of x into dx. This will be the force that is acting on each element of thickness dx. The negative sign after integrating the force will give us the direction that is opposite. The minus sign just says that it will be opposite to the direction of the gravitational force acting on the rod. So if we integrate this gravitational force and find the total force, 4 pi g rho lambda upon 3 is a constant. All of this can be brought outside, and just an integral of r minus x with respect to x from the initial depth was 0 to the final depth was r by 5. If we integrate, we will get the actual force that is required. But since it's in the negative direction, all we have to do is add a minus sign over here, because both the forces are in opposite directions. After integrating the total weight, this will be opposite to the required force to be held up. Now that's it. If we do the integral, we will get half. So 2 pi g into rho lambda upon 3 into r minus x the whole square. Yes, r minus x the whole square will be left, and at the extreme points, we will see that r minus x at r by 5 is r by 4r by 5. 4r by 5 minus of r square. Yes, 4r square by 5. So 4r by 5 the whole square becomes equal to 16 r square by 25. 16 r square by 25 minus of r square, that is 25 minus 16 is 9. 9, right? So 9 into r square by 25 will be the integral after putting limits. 9 only, right? Nothing else. Yeah, that's right. That's right. 16 minus 25 will be 9. Yeah, 9 will be the answer. Now, if we calculate, if we put the value of rho as the value of rho, do we have any other hints? Value of lambda we've been given as 10 power minus 3, and yeah, that's about it. Radius of the earth is given as 6 into 10 power 6. So the value of r will be 6 into 10 power 5. Value of r is 6 into 10 power 5, and the mass density of the earth we can now substitute as mass of the earth upon 4 by 3 pi into radius of the earth cube, or we can write 4 pi downstairs and write 3m in the numerator. This will be the mass density of the earth, and by equating g is g into m by radius of the earth square, we will get the value of m in terms of radius of the earth as m is equal to g into radius of the earth square upon gravitational constant. So the value of rho, if we had to substitute, then we can write as m as g r square upon capital G. So we can expand this as 3 by 4 pi r e cube into m is g into r e square upon G. So value of mass density will be r e square and r e will get cancelled. So 3 into g upon 4 pi g into radius of the earth. Substituting this into the density and calculating the value of g is 10, and the value of capital G, gravitational constant, will anyway get cancelled. So the numerator 2 pi g upon 3, 2 pi g upon 3 into rho will be equal to pi g, and 3 will get cancelled, 2 will cancel 2. So simply we have g upon twice of radius of the earth. This will significantly ease our calculations, and since capital R is given as r square by 100, yeah, r by 100, one of the r e will get cancelled and radius of the earth upon 100 will come in the denominator. I think the approximate value, yeah, approximation can now be done very easily. 9 by 25 from here, and remaining is re square by 100. One of the re will get cancelled. 5 into 9 by 25 into radius of the earth is 6. 30 upon 25 into 9. So it will be a little greater than 1, but not enough for 120. So option B will be the answer over here. Again, you have been given calculator, you can easily calculate now and find the exact answer. It will be surely 108. Let's look at the next question. Here we have a pendulum executing simple harmonic motion. Maximum kinetic energy is given to us as K1. If you don't know the value of kinetic energy during SHM, you can simply know the maximum value of kinetic energy is the total energy of the SHM, that is half into m into omega square into amplitude square. This is the maximum kinetic energy. Now, if it performs SHM with the same amplitude, but length of the pendulum will get doubled. Length of the pendulum gets doubled. We know the time period of oscillation of a simple pendulum is 2 pi under root L by G. G is constant. If we know the expression for time period as 2 pi by omega, time period is also 2 pi by omega, we will get the value of the angular frequency omega as under root length of the pendulum upon the acceleration due to gravity. Right? This will be the value of acceleration due to gravity. Now, when we say that it is executing SHM with the same amplitude, what we mean is the same angular amplitude. The amplitude we can write as length of the pendulum into the angular amplitude theta naught. Theta naught can be the angular amplitude. If the length of the pendulum is doubled, then the new value of A dash will be equal to twice of L into theta naught. That is, the amplitude also gets doubled. Right? Amplitude of the pendulum also gets doubled if we double the length. So, if we now find the new maximum kinetic energy K2, K2 will be half m omega dash square, half to m into omega dash square into a dash square. That will be a half into m into omega square into a square, which was the old K1. This is just K1 into value of omega square will just be value of omega square. If length is doubled, then omega dash square will be equal to twice of length upon G. That is twice of the original omega square. So this will be omega square becomes double. So into 2, and amplitude increases 4 times. A dash square increases 4 times. So into 4. So we get K2 is equal to 8 times K1. K2 is 8 times K1. That is not matching with the answer. So yeah, now we can understand that they did not mean the angular amplitude. They meant the actual linear amplitude of oscillation will be the same. And even if length is doubled, the amplitude in the x direction will stay the same. Hence, a dash square, no, a square. So K2 will be twice of K1 is the answer matching. Again, very, very easy question. Just the calculation has multiple steps involved, and if you don't have patience while solving questions, then you will lose your focus and you will not be able to keep up with all of the steps. Remember, in NEST, the questions are very, very lengthy. You will not have enough time to check each and every question. You will have to do multiple steps. So please don't lose patience. Solve each and every question with much patience and keep on it. You may not get the answer in 1 or 2 steps, but after 3 or 4 steps, you will surely get the answer. This will be the charge that is included in this strip dr, and integrating we get the total charge at some radius r. Total charge at some radius r we can get by integrating this value, that is 4 pi into integral of rho of r into r square with dr from 0 to r. So this is how we can relate the charge at any radius from the radial charge distribution. Now, if we complete the statement of Gauss law, we know that electric field is constant for any radial distribution. So electric field, that is 2 into A into R into 4 pi r square should be equal to the charge induced upon epsilon naught. Electric field also we can expand here itself, 2 into A into R. So charge induced we can calculate from here as Q inside is equal to, at radius R of course, Q at radius R is 8 into pi into epsilon into A, 8 pi epsilon naught into A R cube. This is how the charge varies. Now, yeah, since we have been given the value of charge over here, we need to find the value of charge distribution rho. Now, since we know that charge depends on r cube and inside the integral that is r square, so the integral will be proportional to r cube only if rho is constant, right? We need the integral to be proportional to r cube, which is only possible if rho is constant. And if rho is constant, then we can write the total charge induced as 4 upon 3 pi into r cube should be equal to, into rho should be equal to 8 pi epsilon naught A into r cube. R cube and r cube will get cancelled. 8 pi will cancel with 4 pi and will leave 2. So radial charge distribution we have 6 pi, there's no pi, 6 into A into epsilon naught will be the only terms remaining, and we can see it matches with option A. Again, whenever you are asked to relate charge with any electrostatic quantity like the field or potential, just keep in mind that you will have to use Gauss law somewhere down the line. The next question says that there's a rectangular conducting loop of dimensions given to us, and there's an infinite wire carrying current of 10 amperes. The loop is moving at some speed v with the direction given as root 3 by 2 I cap plus half j cap. We can see this is simply cos of 60 degrees and sine of 60 degrees. So, cos of 30 degrees and sine 30 degrees. So, the velocity is clearly at an angle of 30 degrees from the horizontal. This is how the velocity is dependent. Now, we are asked if the resistance of the loop is 0.1 ohm, then we need to calculate the speed v such that the current flowing in the wire is coming out to be something from the information to be given. Yeah, speed v and current of 10 microamperes is provided to us. So we need at the end that the induced current should be 10 microamperes. Of course, this current will be induced due to the magnetic field created by this straight wire. And we know the magnetic field created by wire according to Biot-Savart's law should be equal to mu naught into current I upon 2 pi r, where r is the distance from the wire, perpendicular distance. So if we consider these two ends, then they will be the only ends that will experience some force due to magnetic field. Rest are just perpendicular to the wire. So if we calculate the value of voltage or the induced EMF, will simply be the voltage difference between these 2 points. You can say this as the motional EMF also. Since the loop is moving, the induced EMF will be due to motional EMF, right? The value of magnetic field over here, let us be 1 and let us this be B2. The value of B1 from this formula, we can write B1 as mu naught into current I upon 2 pi into distance in B1 is given to us as D. 2 pi D will be the magnetic field created due to the wire at the first edge of the loop. Now, again, we can substitute the value of I. Mu naught by 4 pi we know as 10 power minus 7. So this will just be 2 into 10 power minus 7, and distance D is given to us as somewhere over here. There should be distance also 4 centimeter. D is 4 centimeter. So 0.5 into 10 power minus 7. 5 half into 10 power minus 7 will be the magnetic field. 0.5 into 10 power minus 7 Tesla will be the magnetic field from this particular. Now, calculating the magnetic field on the other end, B2 is simply mu naught into I upon 2 pi into D, that is 4 centimeter, plus the side 4 centimeter, that is D plus A is 8. Right, so instead of 4 centimeter, we have 8 centimeter over here. So the magnetic field will be 0.25. This will be 0.25 into 10 power minus 7, just half of that. So the EMF induced in this loop will be equal to magnetic field difference into the rate of change of area. Difference in magnetic field again will keep changing, and area will also change. What will be the change of area over here? Simply the length of the side, 2 centimeter, let's call it B, with the perpendicular component of the velocity. Only the perpendicular component of velocity, Vx, will cause motional EMF, because as the wire moves in a horizontal component, the magnetic field through the loop will not change, and hence there will be no change in flux. The only change in flux happens due to the vertical component of the velocity, and since the vertical component is half, this will be simply V by 2. This speed V by 2 will provide the change in flux. So the induced EMF will be B1 minus B2, B1 minus B2 into B into perpendicular component of velocity. And if we need the current, all we need to do is divide by the resistance of the wire, again, which is given to us. This will give us the induced current in the wire, and that should be equal to 10 microamperes. Very, very straightforward calculations. Once we have Vx, then we can simply double Vx and calculate V also. Now we know the values of dB2 is 0.25 into 10 power minus 7. The resistance is 0.1 ohm. So this will be 0.25 into 10 power minus 7 upon 10 power minus 1 ohms. And the side length is 2 centimeter, that is 2 upon 100. And the component of velocity we need is V by 2. And this should be equal to 10 microamperes, 10 power minus 6 in SI units. Now all we are left with is to calculate the exact value of V. 2 and 2 will get cancelled over here. 0.25 is 1 upon 4. So 0.25 going into RHS will give us 4. From here 10 power minus 6 will get cancelled with 10 power minus 7, and 10 power minus 1 will be left, which will get cancelled with the denominator over here 1. And yeah, once we take 0.25 as 1 upon 4, the 4 will go into the RHS, and since every other value is in centimeter, the value of the speed will be 4 meter per second. 4 meter per second will be the value of V. Again, the calculation is pretty straightforward. All you need to do is keep in mind what the value of mu naught is also again given, and how can we simplify our calculations by taking smartly the variables or the components that we'll be using in our calculations. If we had instead taken everything in terms of Vx, then one extra step of calculation would have been required. Let's look at the next question. In this one, we are provided the fact that bulbs are designed by keeping in mind that resistance of their filaments increases with temperature. We have been given the values of the power ratings 40, 60 and 100, and their corresponding resistors also. Now we need to understand what exactly a power rating means for the bulb. It means that the bulb generates this much amount of power if connected with its voltage rating and its corresponding radius. So we can see that since 100 is obviously greater than 60 and obviously greater than 40, as power depends on 1 upon R, for a power rating of 100, it will require the least amount of resistance. So since 100 is greater than 60, greater than 40, that means 1 upon r at 100 should be greater than 1 upon r at 60, and again greater than 1 upon r at 40. Again, this question tests how much conceptual understanding you have, and if you understand what the voltage rating and the power rating of these bulbs vary. Since they are kept at room temperature, then just the power ratings will increase the joule heating in the resistor, and hence the value of resistance will be different. But again, they are very easily checked also. Let's look at the next question. In this question, we have been given an arrangement of charges, and we are asked to calculate the potential at this point P, which is kept at distance of 5 times A from this point, that is the origin. Now let us label this diagram first. Let's call this triangle ABC. ABC is our triangle. Oh wait, yeah, let's write B at the familiar charge, and let's write C at the charge 2q. Now let's call this point P as it's already done for us, and let's call this central point as D. Now to find the value of potential, we need to calculate the distance of the point P from all the 3 charges that are given to us. But the angles are also given to us. Angle of this is 45 degrees and this is a 90-degree angle. So the other inside angle should also be 45 degrees, right? This is a 45-degree equilateral triangle. That means the length of the side A over here should also be the length of the height A over here. Since both the angles are 45 degrees, both of these sides should also be equal. And similarly, if this angle is 30 degrees, if this angle is 90 degrees, then the inside angle should be 60 degrees, so that in a straight line, all of the angles add up to 180 degrees. Now, this other angle will also be 45 degrees because we are given the line is a bisector of the angle. From the angle property, we can calculate this much. Since the above angle total is 90 degrees, it's a perpendicular right angle triangle. One of the angles being 45 degrees should cause the other angle to also be 45 degrees. So from this, we can use geometry to calculate the angles in the triangle. Now, we don't really require these angles. What we need are these distances. So let us write RA as the distance of point P from A, RB as the distance of point P from B, and RC as the distance of point P from C. Knowing properties of angles, we can relate it to the sides of a triangle by using something called a cosine rule. If you don't remember, cosine rule says that in any triangle, if this angle is theta, and the sides are given as A, B, and C, then cosine rule says that cos of theta is nothing but A square plus B square minus of C square upon A into B, twice of A into B. This is the famous cosine rule. You must have studied this in maths from the chapter Solution of Triangles. This is what we will be using to solve for the distances of each of the charges from the central point P. Now we can just use the cosine rule at various angles. Since we require the distance of A and P, and we know the distance A, P, and D, this is 5 times A, this is A. So we can use the cosine rule in this particular triangle APB and calculate for the side RA. Let us see, this is 90 degrees and this is 60 degrees. So the total angle will be 150 degrees. So for the value cos 150, which we know to be cos of pi minus 30 degrees. So this will be nothing but cos of 30 degrees itself, which is, minus cos of 30 degrees itself, which will be minus of half, right? Root 3 by 2. This should be equal to root 3 by 2. And from the cosine rule, we can write this cos of 150 degrees as the opposite two angles square, that is a square plus 25a square minus of this ra square upon 10 times a, because 2ab will give us 10 times a. And since this angle has to be 150 degrees, it will be root 3 upon 2. 2 will get cancelled with 5, and hence we will get the value of Ra as this A will go over here, root 3 into A, and Ra will be 26a square minus of root 3 times a square, root 3 times a square. So square root of 26 minus of root 3, 26 minus of 5 root 3, sorry. So value of Ra from here will be square root of 26 minus of 5 into root 3 times A. This will be the value of the distance from A. Similarly, we can calculate the distance from B also by considering this side, and we know this side and this side also. We can take this angle 30 degrees since it is given to us. So again, cos 30 degrees will come to us. Oh, sorry, the value of sin theta is minus root 3 by 2, so there will be a plus sign over here. Great. Similarly, cos of 30 degrees should be equal to, from this triangle, opposite two sides, and this is the opposite side, right? A square plus 25a square minus of rb square upon 10a square, similar, root 3 by 2 will be there. And if you notice that the difference is just in the sign of plus 3 and minus 3, we will get the value of rb from here as simply root of 26 minus of 5 root 3 into a. This will be value of root b. Can I write it in a smaller way? No, I can't. So let me shift this calculation downwards so we can make a room for the other calculations also. This will be similarly for RB, and if we want to take RC, then we know the value of RA from here, but we don't yet know the angle between here. So we need to construct a triangle such that we know the angle also, and we also know the various distances, which we can see is this triangle CD and P. In CD and P, 60 degrees is given to us. This is A, this is 5A. So we will get a similar relation for 60 degrees also. Cos 60 degrees is simply half, should be equal to same a square plus 25a square minus rc square, and in the denominator we will have same 10a square. Now since everything is in terms of a, 5a will go to the other side, and 21 root 21, so value of rc will be square root of 21 into a. So right, like this we have all of the expressions for Ra, Rb and Rc in terms of A. The only thing we need to do is calculate the value, exact value of potential now. So value of potential will simply be kq upon r square. Potential will be k into q, negative q over here, so minus of kq square for the first one upon Ra. Value of Ra minus of k into q square for second one upon Rb plus 2 into kq square upon Rc. Oh, sorry, not square, just value of q we need, because we need to calculate the potential, not the potential energy. Kq will be constant, that is 1 upon q upon 4 pi epsilon naught will be constant. And if we simplify the denominators Ra, Rb and Rc, yeah, all we need to do is simplifying this r1 upon ra plus 1 upon rb. In the denominator, we will get an a square minus of b square form. That is 26 square of 576 minus of 676 minus of 5 root 3, that is 25 375. 676 minus 75 is 601 approximately. We'll get 601, and value of RC is root 21. If we add that to the mix, 601 into 21 square, approximately in the denominator, approximately we will get multiplied by 4 will be 25. Yeah, 621 plus 21, approximately 625, that is 25 into 4. So value will be approximately 1 upon 100. Q upon 100 will be the approximate value. Again, approximation is necessary over here, and it is also given. We need approximate potential, not the exact potential. This question says that in an oil drop experiment, negatively charged droplets of mass this much and this much are behaving differently. Q1 charge is remaining suspended while Q2 falls through this much distance in 0.25. So we can find the acceleration of Q2 as 0.25 is the time. So 0.125 should be equal to half into A into 0.25 the whole square. Right, so acceleration of A will be A by 2 into 0.25 the whole square is 0.0625. 0.0625. And 0.125 will cancel with 0.625 as 125 into 4, right? Not 4. 5. Yes, this cancels with 0.125 and we are left with 5. So the acceleration is just 10 meter per second square. Acceleration we get as 10 meter per second square from the information provided to us. Now, we need to calculate the exact ratio of charges on both of them, right? So let us use the first fact that Q1 remains suspended. That is, the force on Q1 is exactly balanced. So M into G should be equal to Q into E, Q1 into E. So we'll get the value of Q1 as whatever electric field is being exerted upon the mass, right? Sorry, Q1, let's be consistent. Q1 will be equal to mg upon E. Or rather, we should calculate the value of the electric field. Electric field we can calculate as mg upon Q1. Now, using the acceleration for Q2, we need, electric field magnitude has also been given, and we have also been given the charge, right? So let's just write Q1 only. Q1 and the magnitude of electric field. That's right. We are given the mass of both the objects, m into A should be equal to whichever is higher. It is falling, right? It is falling from rest. So mg minus Q2 into value of electric field will give us the charge Q2. We can write mg as simply Q1 into E if we want the value of the force, but no, that's fine. That's fine. We can calculate the value of charge from here. Acceleration is 10 meter per second. Wait, is 10 meter per second right over here? Half into A into T square. It is falling from rest, right? I think I might have made a mistake in the acceleration. In the acceleration, I might have made a mistake as they fall through vacuum, right? What will be the acceleration? A from here we get 0.25 square. Yes, 0.625 we are getting. Multiplying 125 by 5 does give us the answer. Oh, so no. This is not a multiply. 0.5 will get multiplied over here. Yeah. So acceleration will not be 10, it will be 4. Acceleration will be 4. Yeah, I had made a mistake. Acceleration will be 4 over here. So ma minus mg would be 6 times m should be equal to Q2 into E. So Q2 we can write as Q2 will be 6 times mg by E. So approximate value Q1 upon Q2 will be approximately 10 by 6. That is, not mg, 6 times m. 6 times m. If we take g, this will be 10 times m. So 10 by 6, you are right. 10 by 6 will be approximately 1.67 is the answer. Again, very, very simple. As long as you can read the question and identify what all forces you should be balancing, then it's a very easy question. Next question, we have been given a prism and we have been given that two mutually perpendicular mirrors are kept, angles alpha and phi are also given to us, and the angle of the prism beta is also given to us. We have also been given that the incident angle and refraction angle is the same, so this prism is at minimum deviation. At minimum deviation, the internal angles of refraction would also be the same, and we know for a prism that a refraction angle plus the inner refraction angle should be equal to angle of prism beta. In minimum deviation, both the refraction angles are also the same, and hence we can write R as beta upon 2, half of beta. Basic prism facts. From the reflected ray, we know this angle will also be alpha, and if we join these two normals, since they are normal to another perpendicular composition, then this angle will also be 90 degrees. So that means alpha plus phi by 2 should also be equal to 90 degrees, that is pi by 2. We can calculate the value of phi from here in terms of A. Phi is equal to A minus pi by 2, that is 2A minus of 2A minus phi, pi we'll get, right? 2 alpha minus of pi will be the value of the angle phi. Now we need the refractive index of the prism. Since we know the incident angle phi and refracted angle r is beta by 2, we can use Snell's law as sine of phi should be equal to sine of the refractive index mu into sine of r. So refractive index phi simply becomes sine 2 alpha minus of pi. Since they are differing by phi, so sine of phi will be equal to sine of 2 alpha. Basic properties of sine function also. So mu will be sine of phi upon sine of r, that is sine of 2 alpha upon sine of beta by 2. Which option is matching? Sine of 2 alpha upon sine beta by 2. B, we can see, is matching from here. Again, basic geometry, Snell's law, and again some more basic trigonometry is all that is required in this question. But once again, questions of NEST are complex. You will not get the answer just by doing one single step of geometry or one step of trigonometry. All of these 3 steps you have to sit through, only then you will get the answer. Next question says that the required minimum distance between object and real image through convex lens of focal length 10 centimeter we need to calculate. Let us construct the system. This is the lens, this is the optical axis, the image distance and object distance let us write as V and U. But since we know that the total distance between them, let's state it as D. From here, if the object distance is U, then image distance should be equal to D minus U, right? Now, if you know this one simple rule of physics, that if you have any condition of maxima or minima, then it implies that there is some symmetry in the system. Necessarily, there should have some symmetry in your system. In this case, you can identify symmetry that U should be equal to V. And since D is equal to U plus V, then U has to be D by 2, which is also the image distance. Again, this is a very, very important fact. You can use this fact for any problem involving physics. It will make your calculations much, much easier. Let's see how. If you had not considered this fact, then you would have had to write the length formula as 1 upon F is equal to 1 upon V minus 1 upon U, and then you would have written V as 1 upon D minus U, and with sign you would have written minus of U, and you would equate your focal length to the 10 centimeter, and then invert the expression, get a quadratic equation in D, and then solve the equation to get the answer. But now that we have the fact that there is symmetry in the system, values of U and V are both D by 2, that means 1 upon 10 should be equal to D by 2 plus 1 upon D by 2, that's equal to 4 upon D. So D should be equal to 40 centimeter. This fact, if you know, turns a 2-minute calculation into a 30-second logical application. Again, this fact is very, very important. If you don't know this till now, quickly note this down and keep it in mind for any question asked to you in the future. This next question says that there is a powerful light source placed at the bottom of a large pool, and we need to find the area of illumination. Why will the area be illuminated? Because we know that if this is the surface of the pool and the light source is kept at this depth, which is given to us as h, let's call this h, the depth is 5 meter, so we can substitute it later. This is h, the depth of the pool. If we consider डेढ़ 2 घंटे, बस थोड़ा 5 सेकंड काट दे इसमें. So if we consider a ray of light incident on the surface at some angle such that it does not emerge in the air, it emerges from the length of the pool, we know this is the critical angle, theta critical, right? Let's consider that the distance between them is r. At a distance of r, we will have critical incidence and the ray of light will graze through the surface. Let us consider. Now we know that theta critical is just sine inverse of 1 upon refractive index of water, right? 1 upon refractive index of water is there. Now we need the area of illumination, so we need the value of r. If we consider this triangle, the normal is perpendicular surface, so in this angle theta c, we can write tan of theta critical equal to opposite upon base, that is r upon h. R upon h, we can write value of tan theta critical. Now we need tan of theta critical if we have been given the value of sine theta critical. It is not at all complicated to find tangent values given sine values. All you need to do is construct a unit triangle, right angle triangle, such that the hypotenuse is 1. Now if this angle is theta critical and the base is, let's say, some b, we know sine theta critical is 1 upon mu. So since the hypotenuse is 1, the height will simply be sine of theta critical, right? And from this sine theta critical, we will be able to find the value of b also, as from Pythagoras theorem, 1 minus sine square theta critical. We have the value of b, so the value of tan theta critical from here, tan theta c, will simply be equal to sine theta critical upon b, that is sine of theta upon under root 1 minus sine square theta. This can also be done if you know that sine square theta plus cos theta is equal to 1. So tan theta, which is sin theta upon cos theta, you can write cos theta in these terms and get the value of tan theta also. If we expand this, theta critical we know is 1 upon mu. So 1 minus 1 upon mu square will give 1 minus mu square in the denominator, and mu square will go into the numerator. This is mu upon 1 minus of mu square under root. This is the value of tan theta critical. We know the value of mu as 1.3. So mu square will simply be 16 by 9, and 1 minus 16 by 9 is just 16 minus 9 root 7. Root 7 by 9, root 7 by 3, 3 will get cancelled. 4 upon root 7 is the value of tan theta critical. This is 4 upon root 7, basic calculation. Now we have been given the value of h, that is 5 centimeter. So value of r will be equal to h into tan theta, that is 5 into 4 by root 7. But we don't really want the radius, we want the area. We can write this as 20 upon root 7. The area of illumination will be pi into r square, that is 3.14 into 400 upon 7. Yes, so 400 upon 7 will be the area. Approximately this should be 200, right? Yeah, approximately, not 200, 100. Approximately area will be 100 centimeter square. Again, the question is quite simple, but you had to do a lot of calculations to get to the simple part, but you can do it very easily. Next question says that a particle of unit mass, so basically we can write it's m equal to 1, so momentum mv will simply be equal to v. We have been given the force on the particle as minus 1 raised to power p into k x raised to power n. We need to check how the momentum versus position plot will be. So basically we are plotting position on the x-axis and velocity on the y-axis, and we need to know how the figure will be. For that, let us check the option 1, p is equal to 1 and n is equal to 2. So in option A, the force will be equal to minus 1 raised to power 1 will still be minus 1. K will be multiplied, so minus of k into x square. This will be the force, and if we write the acceleration as v into dv by dx, we will get minus of k into x square with dx should be equal to v with dv. If we integrate on both sides, we will get a v square by 2 term on the RHS and x cube term in the LHS. Whatever the graph would be in x ki power cube, it will definitely not be a hyperbola, because hyperbola has maximum power 2 in both x and y. Let us check option B now. Option B, for p is equal to 1 and n is equal to 1, the force will be equal to minus of k into x. We know this is a simple harmonic restoring force, and for a simple harmonic motion, we already know how the velocity of a particle behaves. V is equal to omega under root a square minus x square. It's a very standard result in SHM. If you take x equal to a sin omega t and differentiate it, you will easily arrive at this particular value. So we have v square as omega square into a square minus of omega square into x square. This is not obvious what kind of a equation is this, but if we divide both sides by omega square into a square, we will get an equation of the form v square upon omega square into a square plus x square upon a square will be equal to 1. We know this is the equation of ellipse, basic coordinate geometry. So option B is correct over here. We did not check the other options also. This is a single option paper. Next question says that we have a Young's double slit experiment with pinholes at z equal to a and z equal to minus a. If the screen is kept in the xy plane, xz plane, then we need to calculate the eccentricity of the second hyperbolic fringe. Why will the fringes be hyperbolic? First of all, if we look at the screen from the front, that is, if these two pinholes are the slits in a screen and the screen with the fringes is kept at this position, there is a light source that emits lights, and these two sources will have interference on the screen. Right now, the distance between the screen and the fringes is given to be h for us. So if we view the system from the point of view of the light source itself, what will we see? Not from here, let us just view the screen from here, so that we'll actually be able to see the fringes, and the pinholes are kept at z equal to a and z equal to minus a respectively. So if we look at the screen from the front, the screen will appear to be square shaped. Let us draw a square over here. This is the screen that will appear to us. Right, let me draw it a little smaller so that we can use the other piece for calculation. This is a very lengthy question. This was the PIQ from 2024, last year. None of the students got this question. Each and every single student I have talked to says that they just left this question. They couldn't figure out what they had to calculate. So be prepared for a very lengthy calculation. Let us see. If these two points represent the points where the slits are kept, then we know that for a bright fringe, the path difference, if this point is some x comma z, because the screen is at the xz plane, then this point will become 0 comma minus a, and this point is 0 comma a, right? This is the x-axis and this is the z-axis we are drawing on the screen. Now, distance between these 2 points, we can write, let this be S1 and let this be S2. For maximum interference and specifically for the second bright fringe, we know that the path difference delta S should be equal to n lambda, that is 2 lambda for second hyperbolic fringe. The first hyperbolic fringe will be a straight line in the middle, so we need the second hyperbolic fringe 2 of lambda. So 2 of lambda should be equal to the path difference. We know that from any point A comma B to any point x comma y, the path difference r is simply given by x minus a the whole square plus y minus b the whole square. Simple Pythagoras theorem will give us the path difference between any 2 points. So for any random point x comma z on the fringe, we can calculate distances s1 and s2. Let us calculate them, and the path difference s2 minus s1 will be the delta s equal to n lambda path difference, right? So this will be square root of s1. S1 is basically x square plus z plus a the whole square minus of under root x square plus z minus a the whole square. If we expand these brackets, we will get, oh wait, let's not expand these first. Let us not expand these first. Let us square both sides first. If we square this side and we square this side, to remove the radical signs, we will be left with 4 lambda square. We will first square them individually, that is x square plus z square plus 2az plus a square plus the same thing, but instead of 2az, we will have minus of 2az over here, right? Squaring the other term, we will get a minus 2az instead of 2az. So 2az and minus 2az will get cancelled when we first add them, and minus of 2 square root of just multiplication of them both, x square plus, yeah, let us just simply add them up again, x square plus all of this plus a square. So only till this much will be the first term. Clone this, it over here, remove the cancellation sign and add this in the first term, and this will get multiplied to the second bracket. So this will be the first bracket, 2ab term, and second bracket will again be the first bracket cloned, but we'll replace plus 2az with a minus of 2az. This will be the total path difference squared. Again, this is minus of 2az, path difference squared. Now, what we can notice over here is that under this square root sign, we have x square plus z square plus a square, x square plus z square plus a square common, minus of 2az and minus of 2az is different. So we can use a plus b into a minus b is equal to a square minus b square form over here, right? Now, I'm sorry, I am rubbing again and again to rewrite in the same line, but trust me, it's a very lengthy calculation. We will require this much amount of space. So that I don't run out of space, I am rubbing in the same line, but this is very easy to see. A plus b into a minus b is a square minus b square. So let us rewrite this as a square minus b square, and we will get a square is x square plus z square plus a square minus of b square is simply 4a square into z square. This is how we are relating the path difference with n lambda. Now, if we add all of these terms, we will get 4. We can add these terms also. This and this adds to get 2x square. Similarly, 2z square and 2a square also. Right? We can cancel one of these 2's and write 2 lambda square as x square plus z square plus a square plus, we can now write this square root sign as a power half, and if we take x square plus z square plus a square, the whole square common, that will come out of the square root. X square plus z square plus a square, we can take common and it will come out, and in the bracket we will be left with 1 minus of, let me not write a square bracket, let me write a regular bracket, 1 minus 4a square z square upon the same thing, x square plus z square plus a square, the whole square, and this bracket will be raised to power half. Now, since we know that the slits are very close by as compared to the dimensions of the screen, we can see that a is a very small value. Compared to z, we can neglect the value of a. So let us not neglect the value of a in the denominator, let us neglect the value of a in the numerator. We can solve this bracket using binomial approximation as binomial approximation. We can use over here that 1 plus small x raised to power a is approximately equal to 1 plus ax. You need to know many things in maths in order to solve physics questions, right? So now our equation will become 1 minus of 2a square z square. This half will basically get cancelled with 2. Now, if we take furthermore x square plus z square plus a square term common, then we will get x square plus z square plus a square. We can take common, and now in square brackets we can write 1 minus of 1 minus 2a square z square upon this same bracket will be left. Yeah. bracket closed, this bracket closed, this will be our expression. Now we can cancel this +1 and -1, plus sign is minus and minus plus. So we will get an equation 2 lambda square. This is 2 lambda square, and this 2 will also cancel with this 2. Now if we simplify this expression again, we will get lambda square is equal to 1 of the bracket will get cancelled, the square of this bracket. So a into z square upon x square plus z square plus a square will be remaining, right? Now we can take these terms to the LHS and get an equation of lambda x square plus lambda z square plus lambda a square is equal to z into a square. So a square, z square, so z square, a square we can write over here. Now it is not obvious straight away what kind of an equation there is, so we will have to simplify it even further. We can take z square with a square to the other side, and lambda, sorry, this is lambda square, right? Lambda square exists everywhere. Lambda square minus a square with z square will come. So lambda square minus a square with z square plus a square lambda square should be equal to 0. Yes, this is the expression. Still, we are not able to see what kind of an equation it will be. So let us take the constant term to the other side. We can write this is equal to minus of a square with lambda square. Now if we divide everything by minus of a square lambda square, then dividing by minus of a square lambda square, this term will be minus of x square with lambda square, right? So let us write minus of x square upon lambda square over here, and if we divide a square by lambda square in this expression, then we will get z square upon a square minus lambda square, upon lambda square minus a square. So we can rewrite this expression also as z square upon a square into lambda square upon a square minus of lambda square. Yes, now we can clearly see that this is an equation for a hyperbola. A hyperbolic equation we can see from here, x square plus something minus y square upon something is equal to 1. And remember, what was the eccentricity of hyperbola? X square upon a square minus y square upon b square is equal to 1. The eccentricity E was given by under root of 1 minus b square upon a square, sorry, 1 plus b square upon a square was the eccentricity of a hyperbola, right? We have the equation of hyperbola. All we need to do is substitute a and b and get the eccentricity. So here the eccentricity E will be given by 1 plus the value of b square is b square by a square. So we have to divide this by lambda square. So it will just be a square upon a square minus a lambda square. If we take a square minus lambda square into denominator, the a square will get cancelled with a square, and we will be remaining with, lambda square will get cancelled, and in the denominator a square minus lambda square, the eccentricity reduces to, b is in the denominator, right? B is in the denominator, and this with plus sign is a actually. So it will be inverse. It will be inverse. A square minus lambda square upon a square will be the eccentricity. So yes, a square gets cancelled and lambda square also gets cancelled, and at the end we have a upon lambda the whole square. Sorry, a square is cancelled, it's not lambda square. A square is getting cancelled. Yeah, this will have a square, not lambda square. The equation will have a square. I accidentally wrote lambda. Eccentricity will be lambda by e, so this will be a by lambda. Yes, eccentricity gets reduced to a by lambda. Oh no, 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 you're right. This is lambda indeed, but a square will get cancelled, so there will be lambda over here. Yeah, lambda by a is the answer. A by lambda we can see is the answer. As you can see, this is a very, very lengthy question. We had to use up the entire board, fill it with equations on every square inch. Only then we are able to get the final answer. That's why no one was able to solve this question in the last year's NEST exam. You can expect one question at least which will be this unsolvable. But as you can see, if you just know your concepts thoroughly, binomial approximation, properties of hyperbola, the fact that constructive interference happens at n lambda, basic concepts will get you the answer after much calculation indeed. Let's look at the next question. Now, in this one, we have identical charges kept on a regular polygon having 20-25 sides. Now, when you see such a large number, obviously you can't add some charge 20-25 times. So, you have to consider that this number should not play a major role in the rest of the solution. Let us call this number as n. For an n-sided polygon, if we consider these as the sides, right? It is a regular polygon, so all the sides are A, and we have kept charges at each and every vertex also. Let's call this charge as Q1 and this charge as Q2. Length will be A. In order to calculate the energy, if we release the charge and after some time the particle next to it is also released. So if we, for example, release this particular charge, initially it had some energy due to the interactions with all of these charges. All of these charges will interact to give us the energy, right? So we can write the value of energy as simply K into Q square, because identical charges upon A n due to all of these charges. Let's call this distance as A1, this distance as A2, A3, A4, so on and so forth. We will have n charges, so n number of interactions. But the nth charge will be its next nearest neighbor. So an will be simply equal to an minus 1, because nth charge is getting separated. N minus 1th distance, let us write clearly, a of n minus 1 will be equal to a, which is a1. Keep this in mind, we will be using just a few minutes later. Now, if we release the second charge also, that is, we will replicate this system. Let us replicate this system and now release the second charge also, right? This much replication is fine. Actually, not fine. Let us replicate the system till here, okay? And if we release this charge itself now, if we also release this charge, then this distance will be a. Let this be a1, similarly let this be a2, similarly, so on and so forth. We will have till a of n minus 2, till n minus 2, because one charge is missing, so there will be one less charge interacting with it. So now let us calculate the kinetic energy when it reaches the maximum value at infinite this separation. We can write the energy of m1 as half into m into v1 square will simply be equal to the electrostatic potential energy initially, that is K into Q square upon A1 plus K into Q square upon A2, so on and so forth. KQ square upon An minus 1 will be the potential energy. And when we release the charge A2, let it attain a velocity of V2 as the maximum value, and since it has n minus 2 charges, we will see that the same kind of expression is there, but for M2 we have only n minus 2 charges in our system. So if we need the difference in their kinetic energies K, we can see that they only differ by this term. They only differ by term KQ square by A, right? So the difference in them K will be equal to 1 upon 4 pi epsilon naught into q square upon a. We need to find the charge on each particle. We can just find by inverting the expression. There will be a square root 4 pi epsilon naught to k into a will be the charge. Option D we can see is clearly matching over here. Question was quite straightforward. You might have been intimidated by reading the question that there is a n-sided polygon. How will we be able to manage? But if you just know the concept that maximum velocity comes by the electrostatic potential energy, then you can simply differentiate the values on each particular charge, find the value of the maximum kinetic energy thus obtained, and from there we can differentiate them. So take the difference and easily calculate the value of charge q with respect to k. This question says that the image of an object formed by a plano-convex lens at 8 meters behind it is real and it is 1/3 the size of the object. Whenever we know that the size of the object is 1/3, you have to immediately recognize that, wait, the image of the object is 1/3, so the image distance will also be 1/3 of the object distance. That is, we can write u is equal to 3 times v. Whatever suits you, we can write over here. And we have that the wavelength of light inside the lens is 2/3 the wavelength outside the lens, which is simply Snell's law, right? Refractive index of the lens will be equal to wavelength in air upon wavelength in the lens, that is 3/2. It is simply a lens made of glass. Now we need the radius of the curved surface of the lens. Lens is a plano-convex lens, right? Let this radius be r. We know that the other radius is infinite because it's a planar surface. A plane surface is just a sphere of infinite radius. So let us apply a lens law over here, but for this plano-convex lens we need a more accurate version of lens law. From lens maker formula we can calculate the value of focal length. 1 upon f will be equal to mu of air upon mu of lens. So basically mu minus 1 into 1 upon r minus 1 upon r2. Since the r2 tends to infinity, 1 upon r2 should tend to 0. And since mu is 3/2, mu minus 1 will simply be half. So the value of f is equal to 1 upon 2r. Focal length is twice the radius of curvature of the lens. Now if we apply lens formula, 1 upon f, that is 1 upon 2r, should be equal to 1 upon v minus 1 upon u. Of course, the value of u is negative. So if we take u with sign, we know that the image distance is 8. So let's write 8 over here. Okay, we can take this in the next term. Image distance is 8. Object distance is 3 times the image distance, that is minus 24. 1 upon 8 plus 1 upon 24 will be equal to 4 upon 24, that is 1 upon 6. 1 upon 6 will be the value of 1 upon 2r. Hence we get the radius of curvature r simply equal to 3 centimeter. Option C we can see clearly matching over here. Again, if you simply know lens maker formula and lens formula, whatever is given in the question, you have to translate this information into mathematical form. First, using the magnification, you will calculate the value of u and v, and next, using the value of refractive index to find, so using value of wavelength, we can find refractive index. Snell's law, keep in mind, first addresses the wavelength of light and then it addresses the angle of incidence and reflection. Let's look at the next question. This says that there's a solid metal ball of radius 1.5 centimeter and has a charge q. Since it's a metal ball, all of the charge should be at its surface. All of the charge should be equally distributed on its surface. We need to find the magnitude of force acting on one half of the metal ball. So this kind of a metal ball, we need to calculate the magnitude of force acting. First of all, we know that the electric field due to a charged hemisphere at the center, if we take any charge dq, it is just 1 upon 4 pi epsilon naught into the total charge q upon radius r and the integral of simply cos theta terms. Cos theta terms is the value of electric field, right? And we can write q as simply charge distribution sigma into 4 pi r square. 4 pi r square, sorry, this r square over here, 4 pi r square cancels 4 pi r square. For a hemisphere, it will be 2 pi r square, not 4 pi r square. And we'll get the value of electric field due to any charge element dq as sigma by 2 epsilon naught cos theta term. If this is a dq charge and it makes an angle of theta with the horizontal, this will be the cos theta term. Basic geometry, you can see this. Now, since we need the force on the rest of the half of the sphere, let us, we can actually write it here itself. Let us consider a ring element, or rather a disk element of thickness dr and initial radius r. The thickness of the disk will be given by r into d theta if the angular thickness is given by d theta and the angle from the horizontal is theta, right? If you want to write the total force on the half charge, we need to multiply it with electric field and the dq of this ring element, right? Electric field we know as sigma upon 2 epsilon naught into cos theta. And if we need the radius of this ring element, we know that from the center the angle is theta. So this radius we can write as r into sine theta. Radius will be r sine theta. And the surface area of this ring element, if we require to calculate the charge, right, the charge of this ring element dq, we need to multiply to find the force. So dq will simply be the charge density sigma into volume of the element, that is simply the area of this 2 pi r into r d theta. Oh, it's not rho, this is sigma. This is sigma into area is 2 pi into r sine theta into r d theta. Simply circumference into thickness will give us the area and hence the charge element also. So substituting the value of dq over here, we will get we don't even need square bracket, it's fine. We can just clone this and multiply this over here. That's it. Now we have the force acting on one ring element. If we integrate this from theta goes from 0 to the half end, that is angle pi by 2 with the horizontal, is made by the end ring. So theta goes from 0 to pi by 2, integrate this from theta 0 to pi by 2 and we'll get the answer. What are the constant terms? First of all, the constant terms, sigma square from here, 2 pi will get cancelled. So the constant terms are 2 pi r square, sigma we can write as q by 4 pi r square and 2 epsilon naught in the denominator. So the constant terms pi r square upon epsilon naught into sigma. Sigma is just, sorry, pi square upon twice epsilon naught, and we can write sigma square as charge upon 4 pi r square. Squaring it will give us sigma square. Now r square and r square we can cancel over here. R square and r square will get cancelled, and what will remain is simply, oh wait, there is r square in the numerator, and yes, r square in denominator also we can write down like this. Yes, now what we need to integrate is cos theta into sin theta with respect to d theta. Cos theta into sin theta with respect to d theta we need to integrate. Oh no, this will be epsilon itself. I was right the first time. I was right. This is just epsilon. This is not 2 epsilon. Great. So now we can write the value of integral cos theta into sin theta. We can write as sine of 2 theta upon 2 with d theta integrating from 0 to 2 pi, 0 to pi by 2, pi by 2. We get cos of 2 theta upon 4. Cos of 2 theta upon 4 is remaining from the integral, and cos of 2 theta at the end points pi minus 1 is 2, right? Cos of it comes out to be 2. Now we can calculate this force as this r square will cancel with one of the r squares over here. 4 square will get cancelled with one of the 4 squares like this. So 16 upon this 2 will remain, right? So we'll get q square upon 16 into 2 is 32 pi epsilon naught r square. Q upon 32 pi epsilon naught r square. Sorry, not r square, simply r. Only r will remain over here. This is the value of force. Which option is matching? Option A is matching, we can see. Very easy question. All you need to do is calculus on electrostatics. This question says that we need to find the current density as a function of r on a radially symmetric parallel system of electrons if the magnetic induction inside the stream varies as b into r raised to alpha. Values of b and alpha are 1 and 2. So value of magnetic field we will get it as simply r raised to 2. Since value of b is 1 and alpha is 2, magnetic field is simply r square. Now we need to find the current density as a cylindrical radial distribution, right? How can we relate current density to magnetic field? We'll have to use Ampere's law. Integral b dot dl should be equal to mu naught into, how can we write the current density in terms of current? Let us consider a radially symmetric system like this. Yes, this is a radially symmetric system, and considering an Amperean loop around its circumference, b into dl will be b into 2 pi r, where r is the radius of the cylinder, right? Now if the velocity of electrons is given to us as v, or any radius r in fact will do, right? So for some thickness dr, we will get the current inside this. So sorry, thickness dr, right? So we cannot consider the entire Gaussian surface. We have to consider a Gaussian surface of thickness r dr, and the current through this Gaussian surface, current will be equal to current density J into 2 pi r with dr, right? So the value of magnetic field into 2 pi r will be equal to mu naught into I. We can, oh sorry, this is di, with dj, yeah, di element, we have to integrate from 0 to the final radius r, j into 2 pi r with dr. 2 pi and 2 pi will get cancelled since it's a constant. Integral from 0 to some radius r. We know the value of magnetic field is r square. So with r, it will be r cube, and this should be equal to mu naught into integral of j r with dr, again from 0 to r. We know that the current density hence should be something proportional to r itself. Current density should be proportional to r, right? But we cannot find the value of current density exactly like this. What can we do? We can differentiate both sides. Differentiate both sides with respect to r, and we will get 3r square should be equal to mu naught into j into r. Integral becomes a derivative and r get cancelled over here. J is simply 3r by mu naught. Option C is matching over here. Again, this is not a very classic question of Ampere's law, but since you know that you have to relate magnetic field to the current density, there is nothing else you can use other than Ampere's law. Let's look at the next question here. This question says that a non-conducting sphere, so insulating sphere, it will not have equal distribution of charges. It is given to us of radius 50 meters and charged uniformly with surface density 10 microcoulombs. Again, see, even if it's not a conducting sphere, it is still getting charged on the surface itself. If it is rotated by some velocity 70, we need to calculate how much the magnetic induction will be. Now, if a charge is rotating in a circular loop, dq is rotating with angular velocity omega in the circular loop, we can write the equivalent current as simply q into 2 pi r upon omega, omega upon 2 pi r. 2 pi by omega by 2 pi, omega by 2 pi r upon 2 pi r we can write. Yes, this will be the equivalent current for a charge moving in a loop. Now, if we have a sphere rotating with some angular velocity, any disk element will form a loop with the same current across it, right? We need to find the magnetic induction at the center of the sphere. So for this, we will have to use the variation form of Biot-Savart's law, right? For any loop, let's this be center, and it is rotating at an angular velocity of omega. At omega, it is rotating. So in order to find the magnetic induction at center, let us consider some ring element of radius r and thickness, angular thickness d theta, we can calculate. So the thickness will be, if this is theta and this is d theta with this theta, the thickness will simply be r into d theta. This will be the thickness of our loop element. Now, the current through this loop we can write as dq into omega upon 2 pi. The value of charge in this, if we have a surface charge density, the charge will be distributed evenly across this thickness r, right? So we can write omega by 2 pi first, and the charge on dq will be sigma into 2 pi r is again value of r into sine theta, r sine theta with r d theta. This is the value of charge. Now the magnetic induction, so this will be di, the magnetic induction along the center from Biot-Savart's law should be equal to simply mu naught upon 4 pi into this I into the velocity. Velocity will simply be r into omega, right? So the magnetic induction at the center due to this charge element we can write as dB, and with respect to I it will be mu naught di upon 4 pi into the charge times the radial distance, right? And that will be 2 pi r into upon r cube will be there. So this current di should be multiplied by another charge 2 pi r sin theta is the total area dl, circumference will be 2 pi r sin theta into r sin theta, 2 pi r sin theta with again r sin theta upon r cube. So 1 r and 1 r will get cancelled with r square, remaining r cube, and we will get the magnetic field induction as dV is equal to mu naught, 2 pi and 2 pi will get cancelled and will give us 2 mu naught di upon 2 r into sine square theta with di. We have a sine theta already present and another sine theta will now get added. For the total current induced, we will have to integrate. We will have to integrate this magnetic field at the origin. So basically theta will go from minus of pi to pi, or just even 0 to pi by 2 we can take the value of theta, that will also not matter. Just 0 to pi by 2 we can take the value of theta. So total magnetic field will be equal to mu naught into di. We can just substitute this thing. So multiplying upon 2r, this 2r, one of them will get cancelled. 2 pi and 2 pi in fact is straight away getting cancelled from here, and r square with sine theta sigma into omega will be multiplied. All we need to do is multiply r square with sine theta. So the total will be mu naught into sigma omega r. One of the 2 pi is getting cancelled, one of the 2 r is getting cancelled over here. Multiplying with di, we can simply write total magnetic field B is equal to mu naught upon 2r is a constant, and r square is also a constant over here, right? The r will go into the denominator, mu naught into sigma into omega will come in the denominator, mu naught into sigma into omega comes in the numerator, and the denominator, one of the r gets cancelled with the other r's, right? So yeah, this is the only constant in our expression. We can take this constant outside the integral, and then we can integrate what is remaining, sine square theta into sine theta, that is sine cube theta is remaining, right? So sine cube theta with d theta from 0 to pi by 2, we can integrate to find the final value of magnetic field. We know sine cube theta integral, it is not that easy to do, but if you know the value of integral of sine theta from 0 to pi by 2, you can substitute that and get the value of sine theta from 0 to pi by 2 sine cube theta. We know that the cube will add a 3 in the denominator after integration, right? And the value of pi by 2 and 0 just comes out to be 2, I guess, yeah, 2. So the final value will be equal to 2 by 3, which is the integral of sine cube theta into mu naught into sigma into omega. 2 by 3 mu naught sigma into omega. All of the values we have been given. Sorry, there's an r term also. R term also will be there. We have been given all the values. All you have to do is calculate the final. Mu naught is 4 pi into 10 power minus 7. Sigma is 10 power minus 5. Omega is 70. R is 15, 10 power minus 3. So 5 minus 2. Everything approximately should give us a value of 30. 30 into 10 power minus 12 Tesla will be the final value, that is 3 into 10 power 11 matches with the option. Very easy, but there is a lengthy calculation involved which you have to see. Next question says that in a double slit experiment, if we have sources of sound instead of light, then we can change the path difference by changing the temperature, and that will change the velocity of sound in gases also. The velocity of sound we know is proportional to square root of temperature of the gas. So if the temperature rises by something, we can use the concept of errors and say that delta V by V should be equal to, this is T power half, right? So half into delta T by T. Delta T by T is 1%. So change in the velocity will be 0.05%, just half of 1%. Now we need to calculate the change in the first maxima obtained on the screen. We know in a double slit setup, Y into D upon D should be equal to lambda for the first bright fringe, right? For the first bright fringe, the value of Y from here we can calculate as Y is lambda into capital D upon small d. Again, all of these are unchanging values, so we need not worry about what exactly the value of this is. All we need to worry about is how much does the value of Y change if we change the value of temperature, right? We already know how much the value of velocity changes. Now we can use V is equal to frequency of sound into wavelength of sound, and from here we can see that the change in V will be equal to the change in lambda. Yes, that is again 0.05%, right? 0.05% will be the percentage increase in lambda also. Now all we need to do is calculate what will be the percentage change in Y. So yes, once again we will have, so not 0.05%, 0.5%. 0.5% will be there, and from here we will get the change in Y also to be change in the wavelength, which will again be 0.5%. So it will be increasing by 0.5%. Very simple question, not very lengthy also. The calculations are also very simple over here, right? Let us take a look at the next question. Now in this question we have been given a uniform charge distribution, that is rho is a constant, and there is this sort of electric field. Now we have two Gaussian surfaces. One is a cuboid, such that if this point is x comma y comma z, the thickness is dx, dy and dz in all of the sides was the thickness. So this thickness is given to us as dz. So we'll be able to find all the points similarly, right? We need to calculate the total electric flux passing through the cuboid. Now since the electric field, let me draw with a different color. The electric field also has three components. This is x, this is 2y, and this is 3z. This is the value of electric field at any particular point, right? So there will be some incoming electric field at this surface and some outgoing electric field at this surface. If any surface has some incoming flux and outgoing flux, we know the flux passing through it is given by the outgoing flux minus the incoming flux, right? So from this we can calculate what will be the total flux passing through all the areas. Let's take this area for example. The area which is in the YZ plane will only have the x component of the electric field perpendicular to it. Both the y and z components will not intersect to this area. So the flux passing through these two areas, flux in the YZ faces, we can write as electric field at this point, that is x plus dx. Of course, the x component of electric field into the area of this surface is simply dy into dz, minus of electric field at x component into dy into dz will give us the flux coming inside and then going outside the YZ planes. And from here we will get x component of electric field is simply x into dx. So this is simply x plus dx and this is x. So we can subtract them easily and get dx, dy and dz is the flux passing through the xy phases of the cube. Similarly, the flux passing through the xz plane will have y component of electric field and nothing else. So similarly, the flux passing through xz phase will be 2 of dx, dy, dz, and the flux passing through xy plane will have 3 dx, dy, dz. The total flux passing through the cube will be summation of all this. 1 plus 2 plus 3 is 6. So neither 3 nor 9 will be the answer. We have to check now the other two options. Now here we've been given to find the charge enclosed in the Gaussian surface, which is a sphere. For that we need to find the charge density that is present in the region. Fortunately for us, we have the total flux passing through the cube. So total flux passing through the cube should be equal to the charge density into the volume of the cube. From Gauss law, charge density into volume of cube upon epsilon naught should be the relation, right? This is the very basic form of Gauss law. Total flux passing through any closed surface is equal to q inside upon epsilon naught. Flux passing through cube is 6 dx dy into dz is equal to rho upon epsilon naught, and volume is simply dx dy with dz. Both these terms will get cancelled and we have the charge density rho as 6 times epsilon. And the charge in the sphere is very obvious now. Charge in the sphere will be rho into 4 by 3 pi radius of the sphere cube, that is 6 epsilon naught into 4 by 3 pi r cube, that is 8 pi epsilon naught r cube. Option D will be correct in this question. All we had to do was imagine the system a little. What will be the flux passing through each and every surface? If we can calculate, we can also calculate the total flux passing through the closed cube and hence the charge distribution also. Let's look at the next question. Over here, we have two wires carrying 12 amperes and 6 amperes such that 12 ampere wire is along the x-axis and the other wire is parallel to y-axis at z equal to d. So it is basically at a perpendicular distance of d from the first wire, and at this point, that is z equal to d, x and y is equal to 0. This is 0, 0, d point. Yeah, and if this is the origin, the distance will still be d. We need to calculate the force exerted at this point due to this particular wire. The current is 6 amperes. What we can do is we can consider a length element of dl on the wire and calculate the force as I in the second wire, I2 into dl cross the magnetic field due to the first wire. And we know that the magnetic field due to a 12 ampere wire, from right hand thumb rule, let me draw with a green color. This is the cylindrical distribution of the magnetic field, right? So at this particular point, the value of magnetic field, we can see it is downwards. Magnetic field will be in the negative z direction. We can even calculate the value of magnetic field, so not white. The value of magnetic field due to the first wire from Biot-Savart's law will be equal to mu naught into current in it upon 2 pi d in the negative j cap direction. dl is in the positive j cap direction, so this cross product is simply j cap cross minus of j cap, and since j cap with j cap has zero cross product, the force exerted by wire is also zero. The system is made unnecessarily complicated for you. All you had to do in here was to recognize that the length element of the wire and the magnetic field are anti-parallel, and hence they will have no force interacting between them. Next question says that we have a 100-turn coil suspended on one arm of a balance. There is some mass initially balancing the coil, and if we switch on a magnetic field such that one of the arms having this much current experiences a force, we need to place some additional mass such that the weight is once again balanced. This is the mass on one of the ends. Initially, the mass was half kg, so the weight will be half into g, that is 4.9 Newton. We are taking g is equal to 9.8, and in this arm we have a coil such that some current is flowing in the coil, and the coil will have its own weight also. The coil has its own weight, which we know is equal to the other weight suspended. So weight of the coil will be equal to 4.9 newtons. Now, if we switch on a magnetic field such that some magnetic force is acting on this arm of the coil, we can calculate the value of the magnetic force Fb is equal to current into L cross magnetic field. Since the magnetic field is perpendicular to the coil, the cross product will simply be 1, and the value of force is current is 4.9 amperes. Length of the coil is 1 centimeter. Yes, 1 centimeter, so 10 power minus 2 meters, and magnetic field is 0.2 Tesla. This is the value of the additional force, that is 9.8 into 10 power minus 3 newtons is the additional force. Now, since initially both of them were balanced, whatever additional force is, it has to be balanced by an additional mass mg that we add, right? This mass force has to be balanced by the additional mass mg. So if we take this as m into g, 9.8 is exactly g we've taken, so value of m is 10 power minus 3 kgs, or 1 gram is the amount of mass that we have to add in order to balance it. Again, the question was quite straightforward. All you had to do was calculate what will be first the weight of the coil, and second, since the additional force has to be balanced by some additional mass, we need to find simply the additional force, and we'll directly find the additional mass also. Let's look at the next question. In this one, we have a parallel plate capacitor of capacitance C, and that has spacing d between the plates, but since we have been given the value of the capacitance C, we don't really need this exact values, but let us see, maybe we need some values. Now, if it is filled with n amount of dielectric layers such that n is a very large number, we can consider that each infinitesimally small layer, let us consider this mth layer. Let us consider this mth layer, thickness of the layer we can consider to be dx, and let it be at a distance of x from the left hand plate. we know that thickness of each layer is d by n. So the distance between the mth layer will simply be m into d by n will be the value of x that we are getting from here. Now we can consider this to be a system of capacitors such that there is a constant dielectric. That dielectric field is K for mth region, right? And since they are connected in series, the net capacitance will be 1 upon C is equal to 1 upon C1 plus 1 upon C2, so on and so forth, for 1 upon Cn. Since we are considering each capacitor to be infinitesimally small, the summation will just turn into an integration at the end. First, let us calculate the capacitance element dc. We know dc is simply epsilon into area A upon the thickness dx, right? Epsilon into A upon thickness dx with some dielectric constant k. What is the value of dielectric constant? K into 1 plus m by n. K into 1 plus m by n is the value of dielectric constant, right? But we can write m by n as simply x upon d. So the capacitance element becomes epsilon naught into Ka upon dx into 1 plus x upon d. This is the capacitance of one element. If we want to find the net capacitance, all we have to do is integrate 1 upon c will be integral of 1 upon dc. That is, we have to integrate from the 0 point to the final d point, right? So all of this is a constant. Epsilon naught k into a is the constant that will come in the denominator. Epsilon naught into k into a is a constant, and 1 plus x by d we have to integrate with respect to dx. Dx upon 1 plus x by d will be the integral. It is, sorry, not, I meant to put the integral sign from 0 to the distance between plates d. This is a simple log integral, and from here we'll get the value of c as epsilon naught into k into a are all constants, and at x equal to d, the value of x by d is 1, and hence log of 2, and in the denominator we have just simply log of 1. So upon log of 2 will be the answer, option A. We can see it is clearly matching. These type of question I hope you have done a lot, considering the varying dielectric as a series of capacitors are a very famous question that will be asked to you. Let's look at the next one. Here we have been given a photoelectric experiment such that a parallel beam of light with this power is incident, such that the work function is just balanced by the incoming light source. Now if we accelerate the photons, sorry, one photoelectron will give one photon, and 500 volts is the accelerating voltage. Now distance between cathode and anode, again we don't really require. All we require is what will be the momentum that electrons will gain once they collide with the anode. They will now get absorbed by the anode, and the momentum that they had gained will get transferred onto the plate as force. So since we have been given the power, we can calculate the number of photons in the energy beam also. Number of photons can be calculated by power, that is 200 upon the energy of each photon, right? Work function is 6.25, so each photon will have exactly 6.25 electron volts of energy. Writing electron volts in terms of SI units, we can get approximately 6.25 into 1.6 is approximately 99. So 2 into 10 power 20 will be number of photoelectrons, and since emission efficiency is 100%, this will also be the number of photoelectrons emitted. Now since we are accelerating with a voltage of 500 volts, we know that momentum given some energy is under root 2 into m into energy, that is under root of 2. Mass of electron is 9.1 into 10 power minus 31, and energy is simply, sorry, we need some more space. Momentum is under root twice to 9.1 10 power minus 31. Energy is charge into voltage. Charge on electron is 1.6 into 10 power minus 19, and voltage is 500. So the momentum of each photoelectron, 9.1 into 1.6, is approximately 100 into 140. So this will be 1.44, sorry. So the square root will be 1.2 into 10 power, there is minus 31 from here, minus 19, so minus 40 into 10 will give 3. So minus of 46, that is after square root minus of 23 kg meter per second will be the momentum of each electron. Now for force, all we need, for a very small time delay, the force will approximately equal to number of photoelectrons into momentum of each photoelectron transferred. So 2 into 1.2, approximately 24 into 10 power minus 4. Yes, 24 into 10 power minus 4 will be the answer. Very easy question. It is mostly calculative. As long as you know how to calculate power, how to calculate momentum with energy, this is very doable for you. Next question says that white light incident on a film with refractive index of 4/3, that is the film is made up of water, like a water surface, you can assume it, right? And for interference with refraction, we consider this as a thin film. One ray of light incident on this will get reflected, and on a screen, another ray of light will, after refraction, again be incident on the same point, right? To find the path difference of this, it will approximately be, we need the thickness. If the thickness of the film is given by d, let me write the arrows over here. If the thickness is given by d, then the approximate angle of incidence, if it is exactly 90 degrees, with respect to refractive index mu of the water, we can calculate we can calculate the value of path difference. But again, we don't really need the value of path difference. All we need to know is, because of reflection, there is an additional phase of pi added, right? And because of this, the condition for maxima, what we take as delta x equal to n lambda, becomes the condition for minima, and delta x is equal to n plus half into lambda becomes a condition for maxima, right? So whatever path difference we have, that will contain the value d, but all we really require is what will be the smallest value of thickness of the film, right? So for now we need what kind of n and n dash maxima and minima we are getting. So since the path difference for both of them has to be the same, we can equate the maxima due to one wavelength, that is n dash plus half into value of lambda for the right is 0.64. So 64 should be equal to n into lambda, that is 40, we can write over here. From here we can find the smallest values of n and n dash. All we are doing is we are equating the path difference with the RHS of the maxima and minima conditions. for reflection. So 32 n dash plus 32, 64 n dash should be equal to 40 times n. Yes, this should be the equation. Or we can divide this entire thing by 8. 8 n dash plus 4 should be equal to 5n. Yeah, this will give us 8 n dash plus 4 should be equal to 5 times n. We need the smallest solutions for this. So if we take the value of n dash is equal to 1 and n is equal to 1, let us see. 8 plus 4 is clearly not true. So n dash if we take as 2, then 16 plus 4, 20. For n dash to be equal to 2, we require the value of n as 4, right? The value of n, if it is equal to 4, we will get the smallest solution of n and n dash, you can see. Now the path difference can approximately be calculated from the refractive index of water, as the thickness is d. So path difference delta x will be equal to 2 times d, because it has to enter as well as exit. For a thin film, it was a standard expression, that is, while going, it will experience a difference of d, 2d. Let me write path difference over here. Yeah, delta x is equal to 2 into d into square root of mu plus half into mu minus half. If you have memorized the result, it will be very quick for you to recollect this. But if you haven't, then you will have to sit and keep deriving this result, right? And this should be equal to, let's take the smallest value of n dash, 2 plus half, which is 64. So I think it should be better to take the 40 value. 5 into 4, we can see it is 20. So this should be equal to 20 micrometer. 2 will get cancelled with 20, will get 10, and refractive index of water is 1.33, plus half will be 1.83, minus half will be 0.83. Multiply, take a square root, and you will get the approximate answer as d is equal to 0.65. Yeah, if you just run some rough calculations, you will get 0.65 as the answer. Again, there is nothing much in the question. As long as you know this result, this question will be done very, very quickly. Next question we have: a ray of light falls on water, and we need to calculate for what angle of incidence will the reflected ray be perpendicular to refracted ray. For what angle of incidence? Let us draw the ray diagram. If the ray of light is falling as such, then the reflected ray will be at the same angle with the normal. Let this be angle I, this will also be angle I, and the refracted ray with the normal will have some other angle R, and they are both perpendicular. To get the relationship between I and R, we can use the fact that in this line, all of the angles add up to 180 degrees. Since this is 90 degrees, then I plus R should add up to 90 degrees. So we can write I plus R should add up to 90 degrees. That is, R is equal to 90 degrees minus I. Or we can also write it in the form that sin R should be equal to cos of I. This is also a way in which you can use these angles. Now, applying Snell's law at this point, we have sin I should be equal to mu into sin R, right? Yeah, sin I for water, the value of mu is 4/3, and sin R was equal to cos I. So this will be equal to 4/3 into cos I. We have cos, sin, cot and cot. So if we want to get the value of cot, angle of incidence, from here if we take sin I to the other side, we will have cot of I to be equal to 3/4. Hence angle of incidence will be equal to cot inverse of 3/4. Again, very straightforward. So just two steps of logic, one to relate I and R and one Snell's law to relate to refractive index will easily give you the answer. Next question says that there is a metal wire of some radius and constant current R is being carried through it. In this wire, the resistance is completely independent of its temperature. We need to calculate the rise in temperature per unit time. We know that resistance of a wire will be equal to resistivity into length of the wire upon the area of the wire, right? If this is the cylindrical wire approximately, that will be the case. And if the current is flowing through it, there will also be some joule heating, right? The amount of energy per unit time, I square into R, we can calculate, right? Constant current I and R is given to us. We can write I square R is equal to M into heat capacity into change in temperature per unit time. The mass of this, if radius is R and length is L, we can write the mass equal to the density into pi R square into L, right? And the area also will be simply pi R square. So substituting exponents of R and M, we have I square into rho of length upon pi R square, small r, R square should be equal to density into pi R square L into specific heat capacity into delta temperature. Since we only need a proportionality, we can clearly see taking R to the other side, delta T is proportional to 1 upon R raised to power 4 or R raised to minus 4. Very easy question, but in the exam when you are sitting, you might get confused. Reading the question, don't get confused. Remember that all questions are doable by you. Next question says that we have a large conducting slab with uniform surface density. Initially, it was some sigma by 2, and finally, we have densities sigma 1 and sigma 2, right? Now, we need to find the final densities facing the positive plate. Let's draw the capacitor over here, capacitor over here. We know the charge density in the capacitor is just sigma. Sigma is the charge density in the capacitor. Let this be plus and let this be minus. And a slab inserted in this will have sigma 1 on this side and sigma 2 on this side, such that the net charge density is sigma by 2. So conservation of charges will lead us to sigma 1 plus sigma 2, that is the net charge density should be equal to sigma by 2. That is the initial charge of the slab. Now, since the slab is conducting, we need the electric field inside the slab to be 0. There will be some electric field due to sigma 1, some due to sigma 2. Sigma 1 will be inwards, sigma 2 will also be inwards, and the capacitor itself will have some electric field from positive to negative, right? So the total electric field, that is 0, should be equal to electric field of capacitor is sigma by epsilon naught, we know, plus sigma 1 will have sigma 1 upon 2 epsilon naught and sigma 2 will have sigma 2 upon 2 epsilon naught. Again, very standard results. Cancelling epsilon naught on both sides, we will have another expression. Oh wait, sigma 2 is in the negative direction, so it will be inverse. So from here we have sigma 1 minus of sigma 2 is equal to minus of twice of the initial value sigma. Now since we want to calculate the value of sigma 1, we can add these two expressions. This is equation 1 and this is equation 2. We can add them. 1 plus 2 will give us twice of sigma 1 is equal to sigma by 2 minus of 2 sigma. That is 3 sigma by 2, hence sigma 1 will be equal to minus of 3 sigma by 4 will be the answer. Option D, we can see it is matching. Again, very simple question. As long as you can imagine the system and you know the properties of conductors and the charges, you will easily be able to solve this one also. Next question says that there is an alternating current of some frequency and a solenoid has some cross section area equal radius is r, right? We need to find the peak values of electric and magnetic energy density through this. First of all, the inductance of the solenoid we can calculate by writing flux is equal to L into the current through it I. And if you know the standard results for inductance of solenoid, you know that inductance is equal to mu naught into pi r square into number of turns per unit length squared. This is the value of inductance, so not current. This is the value of the inductance of the solenoid, mu naught into pi r square into n square. Now, since the current is producing magnetic field inside the solenoid, the energy density of the magnetic field will simply be the energy provided by the current, that is the work done by the current inside the solenoid. We know that the energy dissipated inside the solenoid is simply half into L into I square. If we want the maximum value of I, we can write, yeah. So the value of energy of magnetic field will be half into mu naught pi r square into n square with maximum current I naught square. Now we need the electric energy, total electric energy we need, and then we can take its ratio, right? We know that electric energy is simply half into epsilon naught into E naught square into the volume. Energy density is half epsilon naught into E naught square. Volume of the solenoid also we can write and get the value. Length of the solenoid L is also involved over here. Yeah, length of solenoid also comes, right? So substituting the value of the electric field we need, right? We know that the value of electric field, or at least the peak value, will just be due to induction, right? Value of electric field will just be due to induction. And inside a solenoid, we can write from flux is equal to L into I, the value of electric field will be mu naught by 2 electric field in solenoid from Gauss law, mu naught by 2 into current I sin omega t, or should we take the value cos omega t for current? No, sin omega t is fine. Mu naught into Ni. Electric field is mu naught into Ni upon 2 to omega I naught sine of omega t. Anyway, sine or cos does not matter, or all we'll be doing is finally cancelling it out. The r terms of mu naught into IR, that is the n into IR is simply area, right? Now, since we have the value of E, the amplitude of E will simply be everything next to the sin omega t term, right? So if we take the ratio, substituting the value of E square from here will be mu naught square into N square I square, everything similarly we can see from here. Everything will be very similar, and the work done by this will also have the volume element, that is pi r square into L will also be there, right? So writing the actual value half into epsilon naught will come over here, and we will get 1 upon 4 into epsilon naught into mu naught n I r omega, everything squared. Yeah, mu naught n I r omega, everything is squared, and finally I naught square will come. Let's see how many common terms there are. Sorry, volume is also there. Pi r square into L is the volume. So how many common terms? R square, N square, I naught square is a common term. Let me underline all the common term. Yes. We don't need I square over here. We already have I naught square over here. Yeah. Everything we have over here. And another common term is one of the mu naughts. One of the mu naught is common. Pi is also common. Length is also common. So when we take the ratio of the energies due to, first we need the electric and magnetic field, right? Electric and energy due to magnetic will be 1 upon 4 and 1 upon 4, yes, it will go upwards, and we will have 1 upon 8. Yeah, 1 upon 8. 1 mu naught and 1 mu naught will remain and 1 epsilon naught will remain. So 1 upon 8 mu naught into epsilon naught, and one of the omega terms, omega square and r square will remain, right? So not epsilon, omega and r, the whole square will remain. But we know mu naught into epsilon naught are related as speed of light c is equal to 1 upon root mu naught into epsilon naught, right? So the value of the ratio is simply 1 upon 8 into omega r upon the speed of light c, the whole square. Omega is 1000, r is 6 centimeter, so 60 upon speed of light, 30 is 8, so there will be 20 into 10 power minus 8 in the numerator, 2 into 10 power minus 7. 2 upon 8 is approximately, we will get 5, 4 upon 8, yeah, 4 upon 8 will be approximately 5, since the only coefficient is matching, that will be the answer. Again, very straightforward. If you know how each and every expression are related, you will easily be able to do this also. Next question, we have that a charged particle is projected from the origin. So let us draw the projection of charged particle. It will be some parabola, and at its topmost point, we need the value of electric field if the charge is q and it is moving. Initial velocity is u and the angle was given to us 45 degrees, right? Now, this is the highest point. So if we draw a perpendicular, this will be the maximum height, and this point will simply be half of the horizontal range. We can draw the position vector r, which we need to calculate, right? Because we know that from Biot-Savart's law, the magnetic field at the origin will be mu naught into q upon 4 pi into v cross r. V cross r at the topmost point will give us the magnetic field. Now, since u has been released with angle 45 degrees, the value of speed at the topmost point will also be Vu by root 2, simply u sin theta. Sin theta is 45 degrees, right? Now we need the value of the position vector r. We know that the value of position vector is simply r by 2 x cap and h y cap. So r is equal to half of the range. R by 2 is basically u square sine 2 theta by g. U square sine 2 theta by 2g is half the range, comma, h is u square sine square theta by 2g, yes. This will be the value of r. Since theta is given as 45 degrees, sine of 2 theta will be equal to 1 and sine square theta will be equal to half. So the R is simply U square is given to us as 10, right? U is equal to root 10. So U square gets cancelled with G on both sides. Sin 2 theta is 1, so half comma 1 by 4 will be the highest point, half comma 1 by 4. And velocity is simply in the y direction, right? Velocity is in the y direction, so V cross R will simply be U by root 2 into the x component of this. U by root 2 upon the x component will simply be, sorry, U by root 2 into the x component, right? So 1 upon 2 root 2. 1 upon 2 root 2 should be the value of V cross R. Now we have the charge, we have the mass. Even though we don't need the mass, we have still been given, right? So the value of magnetic field we can now easily calculate from this question. Mu naught by 4 pi is 10 power minus 7 Tesla, and charge is 0.1 coulomb into V cross R is 1 upon 2 root 2. Yes, approximately this value will be 1 upon 2 root 2 is 2 into 1 by 732. So approximately 1 upon 3. Yes, 1 upon 3. So 3.2 should be in the numerator. Yes, 3.2 10 power minus 8 is the approximate value of the magnetic field. Again, just you need to keep in mind that NEST loves these kind of questions relating kinematics with Bart's law was a very big leap. You can expect such questions in your exam also. Next question says that there are two particles of mass m and 4m having charges q and 2q. They are rotating at radii r and 2r. So smaller radius has bigger charge and bigger radius 2r has a smaller charge. We need to check the options. The angular frequency will be inversely proportional to radius of their circular orbits. Angular frequency we can relate with angular momentum. Angular momentum is mvr, that is m r square into omega. mr square omega is the angular momentum. For a circular motion, angular momentum is always conserved, right? So from here, the angular frequency W should be proportional to 1 upon r square. So not inversely proportional to radius, but inversely proportional to square of the radius. Next says that angular frequency will be equal if their angular momenta are equal. So if L1 is equal to L2, L1 is equal to L2 implies m into r square, m into 2r square, sorry, m into 4r square, 2r the whole square into omega 1 will be equal to, the mass is 4 times m into r square into omega 2. So m r square and omega, sorry not omega, m and r square will get cancelled and we will have omega 1 equal to omega 2. Hence, yes, option B is correct in this question. And since we know that only one option is correct in the entire paper, we can safely say that this is the only correct option also. Now, in this next question, we have been given that the force of attraction between electron and the nucleus of an atom is just Coulomb's law. I think it is nothing new to us, not even need to be mentioned. And if the electron jumps from R1 to R2, if this is R1 and this is R2, electron is jumping between them, then we need to calculate the decrease in the energy of electron. We know that electron was moving with speed v1 and with speed v2, right? If we know the value of v1 and v2, then we can subtract their kinetic energies and easily calculate the total energy difference. We know the force of attraction. Let us try to calculate what will be the value of V from here. The force of attraction we know is K to E square upon R square. This should provide the required centripetal force M into V square by R. So from here we get the value of M into V square. 1R and 1R will get cancelled. It is K into E square by R. The value of mv square we get from here is kv square by r, right? Now the difference in kinetic energies k1 minus k2 will be equal to half into mv1 square minus half into m into v2 square. We know the velocity mv square simply depends on r. So the decrease in the total energy delta E will simply be half into mv square difference. So k e square by 2 is a constant, and 1 upon initial radius r1 minus 1 upon final radius r2 will give us the exact answer. We can see option A. Option A. Oh, not option A, it doesn't have an E term. Not option A, it does not have an E term. K e square by 2. So option C is matching over here. This is negative. So option C will be matching, right? Just to get rid of the minus sign, we will flip the terms R1, R2. So yeah, that's the last question. As you can see that all of these questions were super duper lengthy. You have to do a lot of calculations in order to get question right.